Good afternoon. Hey, first off, I want to welcome everybody. It's really great for you to be here. We're super excited. And this, although I registered the tutorial as Ted Patrick, this presentation is by the entire PyScript team. Everyone who will present today is a core maintainer. Fabio is the creator of PyScript. Hey. And we're going to take you through building apps, where we see things going, what the current APIs hold, and also kind of we want this to be interactive. So we've built into the time schedule plenty of time for question and answers. If you have an immediate problem in getting an application to work, just simply raise your hand and one of us will come to you and sort the issue out. But if you feel the issue relates to anyone else, please feel free to go to the microphone and just ask the question, okay? And we can cover it. We can cover it that way. But we want it to be interactive, and we want you to feel like you walk out of the session knowing how to build PyScript apps, how to deploy them, how they work, and the like. So first things first, for this, if you want to participate in the demos and code along, you'll need a computer. Most of the things that we're going to be doing are on PyScript.com. PyScript.com is a SaaS product. It is free, and the free part allows you to create apps. You get your own subdomain, and you can publish as you want. So if you go to PyScript.com now and sign up, you can basically participate when we get to the coding part after my section. So we're going to spend some time going through a handful of things. My name is Ted Patrick. I am the PyScript engineering manager. And so I manage the broader PyScript team, both the open source and also the .com product. And I'll talk a little bit about what is PyScript and the who and the why. But then Nicholas is going to take you through actually building an app from scratch. So in PyScript.com, we'll build up a working application. And then we have some breaks. You can either choose to stay and talk to us, ask questions, and kind of we can debug apps and the like. But we built in a couple breaks throughout the tutorial. And next, we're going to head over to configuration. Madhur is going to be handling configuration. And the configuration actually is an area that there is a lot of issues with it because it's really about setting up your environment, loading the right packages, and getting things set to run. And then Jeff is going to be handling events and interop. So how do we talk from Python to JavaScript, and how do we talk from JavaScript to Python? But also, how do you trigger events? How do you capture events, interactions with the browser DOM, and also events within the lifecycle of PyScript? Fabio is going to be covering plugins, and then I'm going to hop back and cover web APIs. So what are the what can you actually use the browser for? Because the browser has a whole bunch of very interesting APIs in it, and you can build very interesting things. And PyScript actually has access to all of those. There's nothing we need to do to actually access those. The interop basically takes care of that. And then our thought was, if anyone has anything to show, we can spend some time going through show and tell, although I imagine some of these sections will elongate to the point where we'll run out of time. So the question I have is, what is PyScript? And I think the best way to put it is PyScript is really a platform that brings Python to the browser and lets you create a configured environment. So because we're running in a browser with no dependencies but URLs, everything is loaded in real time. So we load the Python runtime. We load the modules directly. Whereas if you were on your desktop, you would be doing pip or conda install and basically building up a local cache. You'd be building a local environment, determining what Python you want. The same is true with PyScript, except everything loads via URLs. So it's really live in the sense that when you publish an application, every time a person refreshes the page, everything loads. Now, there are some caching methodologies that we're working on to try to improve that, And we're also working on multiple runtimes. So our the Pyodide runtime versus the MicroPython runtime are very different sizes. But it sort of determines, do you want full CPython or do you want a subset of Python that is light and fast? And it just depends on what type of app experience or app you're building. And as we build these out, ideally we have a unified platform that lets you, with either runtime, either run apps or the like. We do provide components for configuration, for adding script blocks, and we also have some Rappel components that let you do interactive eval loops. But I think the title of this talk, it was interesting in terms of us mentioning serverless, but you can run everything locally. There is no server required. You can run these off of any HTML file, regardless of where that is. Now, there are benefits to running on a web server under HTTPS because the web platform exposes functionality when you are secure. So you get to use WebRTC, you get to use WebSockets, you get to use some other security constructs, and also you can interact with other services and the like. So I wanted to take you through kind of a really high-level way to think about PyScript. So our stack is built upon the browser. That is our foundation. And the browser has APIs, and recently, probably in the last 3 years, WebAssembly or WASM has become a application virtual machine target that you can actually feed it native code. And that native code is put into it's compiled to bytecode, and when it runs in a sandbox. And because it runs independent of the browser, it's sandboxed in a fairly unique way to allow you to you can run C things and have it not do dangerous things to your local machine. So it is a very good containerized solution for sandboxing code. On top of that, the two runtimes that we support are built upon WASM. So we work with the Pyodide team, and we're also working with the MicroPython teams to build up these runtimes so that they're compatible and have the features that we need. And then really this is where PyScript comes into play. So the script tag that is when you load PyScript as a tag, it sets up all of these things. It sets up the runtime, it instantiates WASM, it gets your code in the right place, it gives you access to the APIs, and allows those things to all talk together. And this is where we begin building upon PyScript as kind of a foundation. Fabio has actually been working, and the team has been working on trying to enable plugins. And plugins are, you can think of them as kind of a module-like thing, but it actually ties into the lifecycle of PyScript. So you can actually know when the Python interpreter begins. You can actually catch loading events and other things, but Fabio is going to go into much more detail about that. But then you can actually just, with pure PyScript, you can actually write applications. And we think about this is kind of the framework side of PyScript, but there's kind of the platform side, which is setting up the runtime, setting up the environment. But you can write PyScript and build anything you want, symbolized by the unicorn, yay. But there's other ways to build stuff. So you can actually use panel inside of PyScript apps. So you can begin to use other frameworks to build logical components and build UI and organize things on the page. And we fully expect there to be a lot more frameworks that arrive above PyScript. We're trying to take away the hard problems and let the Python community innovate on top of PyScript. And we think there's a place there. Actually, we think there's a strong enough case to where we're starting to dabble in frameworks on our own. We'll actually demo what we're referring to as PyperCard. PyperCard is it's basically HyperCard ported to PyScript. And if you're familiar with HyperCard, it was a precursor to the web, early Apple way to build interactive cards. And I think, Nicholas, you'll go into that just a touch. Yeah. But also, other people are going to build interesting things and fully anticipate that we're not going to build the world's best framework. We want to set it up so that the Python community does some of that. And we support that innovation. We actually encourage it. And at this point, I think I'm going to turn it over to Nicholas, who's going to walk through coding a PyScript app.
Hi, folks. How are you all? Very quiet.
Good.
Fantastic. This is what I like. So I just want to find out a little bit about you folks first. How many of you used PyScript already? Wow. So you're all PyScript beginners. Right. Okay. This is good. So my task is to help you create an app. And I'm going to do that in about 20 minutes. And everything that I show you is going to be a high-level view. But what we'll do is cover most of the core concepts that you need to know about PyScript. Okay? And then my glamorous assistants over there will go into a lot more detail about the various core concepts that I will have introduced in this very simple introduction. Okay? So, you should all have, I hope, an account on PyScript.com. So what I'm going to do is put my glasses on so I can see what I'm doing. And you are welcome to code along, okay? I like it. I used to be a school teacher, okay? And so I really love it when people interrupt me and, ask me questions. So please do that. So without further ado, if we go to PyScript.com, yeah?
Why is there a PyScript.com and a PyScript.net?
Okay, that's a very good question. So PyScript.net is where we have all our documentation and things pertaining to the open source project. PyScript is an open source project. So you're all free to contribute to PyScript. In fact, we hope you do as well. PyScript.com is something that Anaconda, who support the PyScript development, have made. And, well, you're looking at it right now, okay? And one of the core sort of guiding principles of PyScript is that, well, we call it for the 99%, okay? We're trying to make coding accessible and empowering for everybody. Python's a very good language for that, but something like PyScript.com and being able to run Python in your browser all of a sudden means that Python is absolutely everywhere that a browser is, which is pretty much the most ubiquitous computing platform on the planet, okay? So that's what PyScript.com is. PyScript.com is perhaps your IDE and deployment environment. You don't have to use PyScript.com, but it's the easiest thing for you to use, okay? Which is why we're using it here today, okay? So what we're going to do is create a new project. And it always gives you a silly name. I quite like Holy Tooth. I've got a nice smile. And I'm going to just talk you through the geography of the project. So clearly, because we're on the web, we have an index.html, okay? And so this is the thing that the browser will load first and define what you can look at, okay? And within that, you can see in the head, we have things, for instance, like a link to a style sheet, and actually, most importantly, the link to PyScript itself. At the back, question, yeah? Too tiny. Let me try and solve that for you. How's that? If I go too big, we're not going to see anything, so I'll keep it. Is that okay? Okay. And then within the body, we have a reference via a pyconfig tag to a PyScript.toml, and then we have the PyScript tag that has a source set to main.py, okay, which is where your code will live. So main.py is just a regular Python file, okay? And then in PyScript.toml, there's not a lot. PyScript.toml is where you configure your environment, okay? So what I'm going to do is use a package that I enjoy using for teaching purposes called R. That's it. Can you work out what R does? Silence. It translates English into pirate. Okay? Now, the first thing you need to know is that R is a package on PyPI. So PyScript will do all the legwork for you to make sure that it's done the equivalent of pip install R, okay, whenever your application runs. Okay? And that's really all I need for the time being. And then in main.py, we've got print hello world, okay? Like I said, the regular Python app. But I need to add something to my HTML, so we've got something to look at. So within the body, I'm going to just write some HTML. So I'm going to give it a title. R. Okay. Oh. There we go. And then I'm going to add a label for something that I'm going to call English, because that's going to be our input. Okay. And then translate English into pirate. Label closes it. Okay. And then what I want is an input. Okay, and the type of input I want is text, okay, and then what I want is, let's see, a placeholder perhaps, equals, type your English in here, ... okay, and then close the input tag. Why is that not working? What have I done wrong? Okay, well that should work anyway. There we go. And then underneath the input, I need to perhaps put a button as well. So, button. ID. Well, we don't need an ID, but I'm going to say the label on the button is just translate. Okay, and then we want somewhere to put the output. So I'm just going to create a div. I'm going to give it an ID of output, and it's going to be an empty div. Okay, and if I click run, let's just see. Okay, there we go. So what we've got is the HTML displaying, and then we've run the Python file, which currently has print hello world in it, which is why you see the result up there. But the important thing that I want you to see is that there's a user interface that I've created using just plain old HTML, okay? And it looks like it's worked, okay? So I can type my English into here and go hello world, for instance. But nothing's going to work at the moment. So what I want to do is connect what's going on in my HTML, in the DOM, to the world of Python, okay? And so, first of all, I'm going to get rid of hello world here and do something Pythonic, okay? So the first thing I need is clearly the R module to help me translate things. So I'm just going to import R. And then I'm going to define a function. Let's call it trans for translate. Okay. Now, what I need is a reference to the input tag into which you type your English here. Now, if you remember, in input.html, I needed to give it an ID. That's what I needed to do. So let's give it an ID of English. There we go. So I could use the DOM's ID to grab it from Python. So I've lost my mouse pointer. So, so the input text is going to be an element with the ID of English. Have you always noticed that, whenever you're presenting and you try and type something, it never goes right? It's like playing the piano. Okay, and now I actually want to extract from that element the English text that you've created. So I'm going to call that English. And that's going to be input text dot element. So I'm getting the HTML element from that. And then HTML elements that are input elements have a value property that gives you a value attribute that gives you what's actually contained within the input as well. So I can do that. Okay, dead easy. Now I need to then translate this. So what I need to do is create something called pirate, and that's going to be r.translate the English. And then I need to get a reference to that output div. If you remember, that's where I'm going to put the result. So output div is going to be another element whose ID was, I called it output, I seem to remember. Output, let me just check that. Div is output, there we go. So I'm grabbing a reference to that, and then, again, output div dot element dot, those of you who are web developers, this will be familiar, dot inner text equals the translated pirate speak, okay? So that's automatically been saved, and if I click run, and I've sacrificed enough chickens to the demo god this morning, let's see if it works. So, it won't work, because do you know what I've done? I've forgotten to do something. Let's see if you can work out what it is. This is cool. Translate. Nothing happens. I click translate. Nothing happens. That's because I've not connected the event in the DOM with the Python trans function. So back in index.html, I have my button, and I can say something like, here we go, find my mouse, py-click equals trans, a call to trans, okay? So I'm saying, when you get the click event, I want you to connect it to this piece of Python that's a function called trans, okay? So, it's saved. Let's try running it again. Hello, PyCon. This is cool. Huh? Let's see. Does this work? Ah! Ahoy, PyCon. I should do it in a pirate accent, shouldn't I? Ahoy, PyCon. This be cool, huh? Okay, so it's working. Okay, now what you've found, what you've seen me do is take things from the DOM, do stuff with it in Python, and put a result back into the DOM, okay? And it's taken me 10 minutes to do that, and I've been typing very slowly because I'm presenting to you lot and I've got 11 fingers and so on, okay? Is there any part of that that people would like to ask questions about? Anything that's not clear? What I want you to take away from this is that it's very simple and very quick to get a working app going. Yeah? Can you show the HTML? Ah, yeah, sorry. You mean widen that? Yeah.
So it's not working. Where do I find a debug console or something going on?
So, for complicated reasons that I'd be happy to explain not up here, you can't just drop into PDB, okay? So we're back to old school print stuff, okay, when you're in your Python code. Often what I do is I will right-click View Console, in the browser and take a look and see what sort of log messages are coming out of PyScript, what JavaScript is telling me is going on, and usually with a combination of that and lots of print statements, I can figure out what's going on. Now, rest assured, we will have debugging. In fact, one of my colleagues, Antonio, he wrote PDB++, and he's desperate to be able to get this working with PyScript. But what we're doing is we're building up the layers of PyScript. We're starting to enable more and more features as we kind of resolve how you get a browser, which is an asynchronous sort of world, working with Python, which is a synchronous sort of place to be. And, you know, we've got a good way forward, but we're working on it, is what I'm saying. Okay. Any more questions about what you've seen? No? Who's got it working? Most people. Fantastic. Great stuff. So if you haven't got it working and you'd like it working, this is where you kind of put your hand up and one of my glamorous assistants will come over and help you. So there's three there. And then because it's just simply a web app, if you click here, the three dots, and view the site, it'll take you. This is the URL that you can send your friends to get their pirate app. And I believe, Ted, am I right? The great big long UUIDs that we use in the URL here are going to be moving at some point? Oh, he's not listening. Okay. Last but not least, I need the audio out. Here it is. No, it's not. Can't find the audio jack. Ah, there it is. Sorry. Good to go? Okay, so Ted mentioned that PyScript has access to all the underlying web APIs. There's an audio object in the browser context. And so this is a little simple test app. You click the goose, and it honks at you. Okay? So I just wanted to let you see that PyScript has access to the whole of what the browser has to offer, okay? And my colleagues will show you how you do that when they get to the interop layer as well. Now, I'm conscious of the fact that I've been talking for about 20 minutes, which is my time up. And there's about 5 minutes for questions. So, any questions about anything to do with what you've seen or PyScript in general? Yeah. That's a good question. So what you're doing is getting state out of the DOM rather than passing arguments in, right? So that's why it's been written in that sort of a way, really. It's just a case of that's just the context of where you're in. Any more questions? Yeah. Yeah.
Element was not important. Is there a bunch of stuff that's in the global?
Yeah, element being one of them. Yeah, that allows you to get access to an element by ID in the DOM. Yeah, what you can do is, if I show you in the code here, you can. So you can import JS. Okay, JS is global this in the browser. It's the window object, basically. So I could do something like js.document.get element by ID. I'm using the underlying JavaScript API here, and then English, etc. And do it that way. But we've started to build kind of convenience for you, so you can very quickly and hopefully Pythonically get to the things that you want to build, the stuff that you want. Yeah.
Explicit is better than implicit.
Yeah.
So maybe element should be something we magically form.
Yeah. Razor, we've got a discussion forum. We're an open source project. Yeah. Well, no, get involved. It's that's what I'm saying. We're a friendly bunch as well. We welcome collaboration and things. Oh, yeah. Okay.
This one, yes, explicit is better than implicit. In fact, the next release we're doing exactly what you mentioned. That was the initial behavior. This last release, we added deprecation warnings for a bunch of the global stuff. And from the next release, in theory, what you should have import in the globals is just basically display, which is a new keyword that we have to disambiguate between print and displaying on the DOM. But everything else should be imported explicitly. So, yeah. Thank you.
Cool. So, yeah.
I think my code works, but I just don't have the auto completion of all the code snippets. For my part is all the red color, so it just don't have the when it clicks the dot, it doesn't.
Yeah.
I don't know why is that.
And you're using PyScript.com? I'm not sure. If you've encountered problems or your code still isn't working, and we're going to be having a break soon, I believe. Ted, is that right? Yes, a break soon. Come tap me on the shoulder and I'll try and help. Okay. One last question. It's all right. And yeah, okay, we've got it working. And so after the break, we'll be getting into more detail about things such as what on earth is going on in PyScript.toml, which is how you configure your environment, okay, how you react to events in the DOM, other stuff that's available to you in PyScript as well. And with that, I'm going to call it a break, okay? If you need me to look at some code because it's not working, and I can see there's at least one person to do that, just put your hand up and I'll come and, yeah, okay. Fabi, if you go to that one, I'll go to this one. Okay, so we're back in 15 minutes, okay? It is top of the hour, so if we come back at 1:15.
.com account and allow you to copy everything of a fully working app. So I think we should share more of these, but essentially we ran into 3 issues where we were seeing latency saving on the server side, and what you were seeing in the browser was not saved to the server. I think we had one here. I ran into it twice occasionally. Yeah, so my apologies for that. It's a detail on the autosave feature that it's saving as you're typing and it's not completing back, and honestly, I'll take it and file a bug now. Yeah.
So one of the common things that I found whilst talking to you folks, whilst wandering around, is that I was always making the point that PyScript is a young project. It's only a year old. And so it's a work in progress. It's lots of features. You can already do amazing things with it. But it's an exciting time to get involved with PyScript as well. If you want to make it work this way, or you want a feature, come and contribute. That's what I wanted to say.
So what you'll see with this URL, if you open it up, it'll open up the code for it, run it, but you have this copy project button, so you can actually copy the entire tree, the entire folder from the server side to your account, and then it's a perfect translation of what's there.
Okay. Well, in this section, we are going to talk about this file here called PyScript.toml, right? Let me zoom into it. So what does this toml file do, and why is it important? So it's a way to specify our configuration for our PyScript application. The toml file is actually used inside a pyconfig tag. It's a way to specify your metadata and dependencies. Although by default we recommend using toml, but you can use JSON as well. And as Nick showed in this previous example, you place this pyconfig tag in the body element as per the web standards. So you can supply an inline configuration or via an external file. In the previous application, you saw it being supplied via an external file because that was a file called PyScript.toml, which was a source for the pyconfig tag, right? And you can do both as well. I'll come to it later. So the only attributes that we have for this tag are type and source. The type is if you're using toml or if you're using JSON. By default, it's toml. We won't go into JSON for this particular tutorial, but it's a one-to-one correspondence, so that should be easy. And source, as you saw in the previous application. So by an external config, this is what I mean. So you have a pyconfig tag, you have a source, which points to a particular file. This is what you saw in the previous application. And then, oh, oops, this is actually inline, not external. So your external configuration is specified like this via the source attribute, and your inline configuration is what you write, basically the inner text of your pyconfig element. We have several configuration options here, such as splash screen, the interpreter that you want to supply. There's a whole set of keys. We'll come to it later, but we'll only discuss the most important ones. So, like I said, you could supply both. For example, here, you have a configuration which is also inline, and you also have a source attribute. So using both of them. Now, what is the use case? So you could imagine a common configuration which is shared by many applications, which can be supplied via your source attribute. But some specific keys could be overridden on a per project basis, right? And so this is how it is useful. So if your custom has, let's say, A equals B, and that is required by all of your projects, and you have C equals D as well, but for your particular project, you want to change the value of C. So then you supply C again in your inline, and that will override what you supplied via the external one, right? Now, you can also specify which interpreters to use. By default, it's Pyodide, and as you can see, if you open a default project on PyScript.com, it won't have the interpreter key because we do it for you. So by default, it's specified as Pyodide. It dynamically fetches Pyodide. And to specify interpreters, you have three keys. The source, which is of course required. The other is this metadata for name and language. An example of how this was done is here, right? So source is where to get Pyodide from, and the name and the language. Now, we can also specify packages. So in the previous example, you saw the library, right? So for specifying packages, you can either have a direct link to the package URL. So this could be, for example, if you have a custom package, which you have custom wheel for, right? And these files actually need to be hosted in a web server. Otherwise, they won't be able to get discovered, right? And also, you can specify some package names and versions. And now, where does it come from? So some packages come with with your interpreter of choice. For example, for Pyodide, if you visit this link, they have this whole set of supported packages with their specific versions. So these are automatically supported, right? Now, if you'll notice, the library, the Pirate library, is not mentioned here, right? That's because even pure Python packages, which are not supported, which are not listed in this Pyodide list, right? They are automatically fetched from PyPI if they're hosted there, and they'll also work. But then the key needs to be here that it needs to be a pure Python package. So it cannot have C extensions. Otherwise, it will need patches and stuff. So NumPy is one which has C extensions. So that's why it needs specific patches to work within Pyodide, and that's why it's a part of Pyodide's offering, right? So the way to do it for a particular wheel is something like this, where you specify the path where your wheel is present, And you can also specify particular versions, for example, 0.14.1 for panel, right? Another use case is local modules. The thing is, you cannot have, imagining everything, all of your Python application code written inside the PyScript tag, it's a lot. So you can, of course, modularize your code, right? So let's say you have this file called data.py, and it has a simple function which generates two random numbers, x and y, right? And within your PyConfig, we have packages for NumPy and Matplotlib. And there's this key called fetch. I'll come to it in more detail later. In fact, it is the longest section because it takes a while. But now we are fetching this file called data.py, which we created here, right? And this, of course, also is hosted on your web server, right? And the code that you have written here inside these PyScript tags is, as you can see, from data, import, make x and y. So you're importing this function which was written in data.py, right? So you can use local modules, and it is one of the use cases of fetch function. And we have a dedicated DDL section for it later. And it is useful in organizing your app into different files and modules, so you can import them later, right? So now comes fetch. Well, this configuration key is used for downloading stuff from the internet or our hosted web server. And now where is the stuff saved? So for example, where is this data.py that you downloaded saved? So the thing is, even if it's hosted on your web server or if it's present on the internet, the files are fetched into and saved into this sandbox environment of the browser. And we refer to it, the technical term for it would be mscripton's virtual file system, as you can see here. Not going into too much details, but mscripton is the tool chain which made Pyodide possible by compiling the C Python interpreter into WebAssembly. Right. So now we have 4 keys corresponding to this fetch section. And as you can see, we use the files key here, right? So we have the from key, we have the toFolder key, we have toFile, and we have files. And toFile and files are keys which, shouldn't be supplied together. Otherwise, you're gonna get an error. These 4 keys, basically the permutation and combination of how we use them. It's a simple and powerful mechanism for a wide variety of users. So let's say you want to rename files, you have to preserve directory structures, and you can, of course, have multiple of these fetch configurations. So this is just one configuration of fetch. You can have multiple of them. By the way, this double bracket fetch denotes an array of dictionaries in Toml. So that's why this is the first element within that array. So you could have one more or more, right? Quickly going over these 4 keys, from is nothing but the base URL of the resource to be fetched. toFolder is your the name of the target folder in your virtual file system within the browser. If you have multiple files, you use files. If you have a single file, you use toFile, or if you want to rename stuff. So this is the basically the algorithm. I'll share the link to the slides. You can read it. But basically, source URL is for each file in files, this files array, your source URL is from plus file, and your destination is toFolder plus file, and you download the object from source URL to destination, right? And there's this blog by Jeff. It covers various use cases of it, but let's go over some examples. So in our examples, we'll assume that we have this following directory structure. So we have our index.html file, and this contains the pyconfig tag. You have an info.txt, you have a data folder, you have sensordata.csv, you have packages, my package, the init, a hello world folder, a hello world sub package, let's say, init, and greetings. So if you want to fetch a single file, you would do, you could supply info.txt as a single element in the files array, and then you can access it in the PyScript code using this. So this is no renaming, no directories, just fetch a single file, right? Let's say if you want to rename, you could use from, and then you could use toFile, and now you can use it here like this with the new name, right? Again, with the following directory structure, if you want to save it if you want to save this info.txt inside info files, loaded info, whatever the directory structure might be, So then you can open it like this, right? So now again, the next example is we are saving the single file to another directory with renaming. So these are some examples. Again, you fetch this single file, you have this way to save it, and what is the new name? And you can access it here like this. And here it's single file from a folder to the current working directory. So if you see here, we have sensordata.csv inside data. So the from prefix is data, and you have the following file, and then you access it via the current directory. That's because you didn't specify two folder, so by default it's the current directory, the two folder key. This is single file from a folder to another folder, which is not the current directory. So the only difference is you specify the two folder key here, right? And now you can access it like this. You have multiple files preserving the directory structure. So you have from, you have all the following files, and notice that you can have paths here, such as hello world greetings.py inside. So this is gonna fetch everything inside this my package directory, right? And now since these are packages, because you have these init files, init.py files, so now you can import it as a package. So from custom package, .hello world, .greetings, import, whatever, say hi. Let's say you have an API which doesn't end in a file name, and this is an actual URL, you can visit it. This gives us a JSON. So I'm saving it via catfact.json, and you can simply import it like this. So there are a few more examples. I'll probably create a bit.ly link of this blog post, and this covers almost all the use cases. But you can have extra keys and values, that is metadata information can also be supplied in both inline config and config from external source. So for example, you are supplying a custom key here, let's say magic, which is unicorn, whatever that means. But this is only for your it's purely metadata, right? And there are a few more keys, but this is the whole reference and specification for this tag, right? And for example, let me show you one example of using it. So here I have this file called harriscornerdetector.py, and it is using OpenCV, it is using NumPy, and it has these functions to do some image processing, right? And it's a pure Python file. There's nothing related to PyDide here. It also has a if name equals main, which won't be executed because I'm not executing this file directly. But here we have another file called imageupload.py, and this performs some voodoo magic to let us upload a file, right? Here is our configuration. So I'm specifying the packages I need. I'm specifying which files I need to fetch. Now it knows where to fetch it because it's in the same file system here, right? And my main.py is my logic to run the algorithm on the uploaded image. So I'm converting it to the underlying NumPy representation and stuff, but not going into details. The app basically is load the configuration via the external toml file, which I showed, right? And have a tag for uploading the image. Run the script for the voodoo magic for letting us upload the image and running the algorithm. So let's choose, let me zoom out perhaps. So let's choose a file. Let me choose this chessboard. So nothing's happening. Now I'll press this button called run corner detection. And yeah, let's wait. Yeah, it takes time because, yeah. So we have our output, and if you see, all the corners are highlighted by these red dots, right? So this is doing some live image processing in the browser, in the sandbox environment. And yeah, so this is the PyConfig tag, and it's very powerful. I recommend you to check the documentation here, and it has everything we talked about. Thank you. Any questions? Yeah.
In the fetch examples you
Currently, you have to specify all files. Yeah.
Can you clarify why you, so you have the query detection and fetch, but you have the image upload in the HTML. Is there a clear reason why the one had to be in fetch and the other one you called directly from HTML?
Oh, yeah. That's because I'm using this Harris corner detector as a module, right? In my main.py, I'm importing stuff from here. So let me zoom in. So from Harris corner detector, I import stuff. So that is also going to be fetched, but then I'm running it directly. So in the index.html, this runs directly using PyScript source. So this is another way if you want to run things directly, then there's no point in fetching, right? You only want to fetch if you want to have use local modules.
So you could have put the Harris corner detection in between those two and not fetched. Is that also true?
Um,
Or would it not recognize as a module?
yeah, but yeah, I think it could work. Yeah, but we haven't tried it. This is a cleaner and more. Yeah. Yeah.
Where do you upload the image? There is no backup, right?
Sorry?
Where do you upload?
Where did I upload?
Yeah,
Well,
where? Upload to, there is no backup.
yeah, there's no backend. There's no backend. Yeah.
Upload to where?
So it's basically, I mean, it's nothing but an image tag. It's inserted as an image tag using the base64 representation.
When you upload something in PyScript, you're always using the
Virtual file
virtual
system.
file system. So your browser has a virtual file system that it writes to.
May I see or can you share it?
Yeah. We can perhaps share this link. Yeah, do you have the?
You can do that later, but
Yeah, okay, I'm going to share it in a while.
yeah, but in general, whenever you upload something in your page, it uploads to your browser, even without PyScript or anything. It has the memory, the image or the file you have in memory. With PyScript, it writes in the virtual file system. If you have a server and you want to upload the image, first you click load the image and then upload send to the server. In PyScript, you don't need to do that extra send to the server. It lives inside your file system. And whenever you do file open in Python, it's reading from that file system, not your local Mac or Windows or other operating systems. Does it make sense?
Yeah, makes sense. Just I want to see code.
Yeah. I think we have several. You don't have a code where you show the image or something?
So this image upload thing, I mean, I can show the snippet, for example. We create a new image tag here, right?
Or
And then-
Ted, or Ted is gonna also
Yeah.
cover it.
And I'm setting this image source as the base64 representation of this data that I get through our handler. So it's just an image tag which is being displayed. Yeah. Any more questions? Thank you.
Well, what we set up, a couple of notes on the packaging. When you're installing a package, you, as Madhur said, you can pass any URL that points to a package, and it will download and install it, etc. If you're specifying the names of the packages, it goes through Pyodide internals, and Pyodide has already a list of packages that they built. The good thing about it is that most of them are packages that have C dependencies, so they just don't work out of the box. You need to compile them for WASM, the WASM platform. So those work fine. If you have any pure Python package that is not included in Pyodide, it will also work fine. Basically, Pyodide will go and fetch them from PyPI and install them. But if you have a need to run a package that has C dependencies and is not in Pyodide, then you will have to compile it by yourself, if it makes sense.
Yeah. I'll put out a plug. The PyDI team has been doing some cool work on that build process. You can basically download the PyDI build tool. It's a lot like CMake, right? You're like building for a new platform, and it works pretty well until it doesn't, right? Because you're building for a whole new assembly environment, right? So, but if you have a package that you want to try and build for WebAssembly, I'd encourage you to just give it a try. A lot of them do just build. Yeah, question?
And does that then a package you end up having to provide as an artifact on your website?
Yeah, exactly. Yeah, you end up building a wheel file most of the time, and you just host that somewhere and point your PyConfig at that. Yeah.
So if the package actually builds a wheel and sends it to the normal PyPI wheels, even C extension wheels that are made in WebAssembly will just work out of that?
Yeah.
That is cool.
It's pretty cool. Yeah, it's awesome. And the reason that PyDI has to host 100 and some odd packages is a lot of things like NumPy, especially SciPy and things that have C extensions that are harder to compile. They've done a lot of that hard work for us, right? But there are other libraries that might not be compiled yet. Yeah. Was there a question back here? Yeah.
When you compile your own package, does it have to be compiled for a specific version of PyDI, or
The short answer is yes, because versioning is tricky. I don't know if you build a version of a wheel yourself. I believe it is pinned to the specific version of PyDI that you build it for, because their API has been changing fairly quickly. But if it builds for one version, it will probably build for future versions, I would say. Yeah.
This is a very new discussion, and a lot is changing. Like tomorrow we have the WebAssembly Summit to talk also about those things. What does it mean to have a Python package on WASM and tied to versions, and also there are different layers. PyDI relies on mscripten. There are other implementations like WASI and stuff like that. Also PyPA. Sorry, do you want to say something?
No, I was also going to say there are lots of talks happening at PyCon about PyScript. So you go to, say, for Antonio's talk, which is about the WASM lower level layer, which might answer some of the questions. There's one that's an introduction about how is PyScript put together. There's Fabio's, which is about what's coming down the line.
Yeah? Awesome. Yeah, all good questions. If you want to talk about, anyone who thinks packaging is easy should come and talk to Fabio, who wants to talk about packaging. But no, good questions, right? I get to pick up some threads. So Madhur has laid the foundation of like, how do you get packages into the browser? How do you get files into the browser? And now I get to sort of build on that and pick apart some of the things that Nicholas said earlier in his demo app that are actually really cool. One of which is the Python and JavaScript interactivity that we get in the browser via the PyDI runtime. And it's actually coming to the MicroPython runtime very soon. I think basically there is a working demo and the API is getting shushed now. One thing that Nicholas said earlier, or you had in your demo app, was this line of Python code: input text equals element, in quotations, English, right? This was something we just had you type in. He said it grabbed a reference to an element in the DOM, which is what it does. It grabbed the contents of that input element that we typed into our HTML. We used that to get the contents out. This line is actually magic in a cool way, because the element in the DOM is represented in JavaScript, and we're working with it in Python. How the heck is that possible? We get the ability to basically treat JavaScript objects like Python objects, and vice versa. We can treat Python objects like JavaScript objects. And so that's what this first part is going to talk about. Ted will get into this more in a little bit when we talk about the plethora of web APIs that gives us access to. All the things the browser can do in JavaScript, we can now do in Python. I'm going to show you the hammer. Ted's going to show you the whole hardware store. I'm going to lay a little base of how JS and Python interact in PyScript. The short of it is, in a PyScript code, or in anything that's running in the PyDI runtime, which is our primary runtime, import.js imports names from the JavaScript global namespace. Now, what does that mean? I'm going to open up my developer console here in the browser. If you haven't done this before, open up your dev tools, open up your console, right? This is the equivalent of our Python REPLs just for your browser window. And if I type in the name of the global object, which in the browser's case is window, and hit enter, you'll see something like this. If I hit this little arrow, and don't mind if you can't read all this from the back, it's thousands of lines long. This is all of the objects, the classes, the functions that are implemented by the browser to let you do webbish things, right? Scroll to, these screen objects, set timeout for scheduling things in the future, all kinds of webbish things that exist in JavaScript. When we use the import JS syntax, we are importing any object we want that exists in this namespace, right? So we'll look at that in just a little more detail. If you were to type into a PyScript tag, this import.js, print dir, our familiar Python dir function of JS. If you do, it will freeze your web page for a few seconds because it's loading those thousands of names. But we basically get proxies to any of the objects that exist in the JavaScript global namespace in Python, right? The power of that is that we can do things like this. And feel free, I'm not doing this in PyScript.com just for text size, right, for those in the back. If you type the HTML parts into your PyScript app and the Python parts into your Python app, it will work. If you add to your Python a paragraph tag, a p tag, with the ID of hello world, and whatever contents you want, hello world seems right. We had you earlier do something like this, p equals element of the string hello world, print p.element.inner text. You'll get out the inner text of that HTML element. What's happening under the hood there, and I want to expose to you so we can go a little deeper, is that the element object is essentially doing this under the hood. From JS, import the document object, which is one of our common ways of grabbing elements of the DOM. If you've worked in JavaScript, this will be quite familiar. And we say that our p object is equal to document.getElement by ID and some ID that we specify. So I grab the element in the DOM with the ID field of hello world. I grab that and I put a Python reference to that object. Then I can grab its inner text and print that out. Either way, we get hello world, right? So taking you inside our API a little bit, we say in Python element, in JavaScript you say document.getElement by ID, same thing, right? So far, so good? Yeah, questions there real quick? Okay, let's dive a little deeper. Once we have access to all of the parts of the DOM API, we can start to make use of it to do more powerful things. If we were to add, say, a couple of paragraph tags to our index.html, hello world, happy PyCon, a couple of paragraphs, we can use more advanced DOM features like query selector all, which grabs all of the paragraph tags or all the tags that match this query in our web page. Now this method, this JavaScript method, document.querySelectorAll, returns a JavaScript I was going to say array. It's at least an iterable, returns an iterable of the objects that we asked for, right? But because we are able to proxy those objects into Python, I can use a normal Python for loop to just iterate over them. I don't have to worry that they're JavaScript objects. I don't have to worry that they're, I can treat them just like Python and iterate through them for element.inner text. And if you type this into your PyScript.com app, what you would get is the inner text of both tags, hello world and happy PyCon, right? Starting to see how we can use the JavaScript methods to interact with the browser in the way that it is normally interacted with, but we get to write Python code instead of having to learn another language like JavaScript. We didn't poll the room. How many people would say they are like proficient in JavaScript in this room? Okay, a handful of these, which is fair. That's where I was when I came to PyScript as a developer. I still wouldn't say I'm a JavaScript expert, but you don't really need to be, right? You can read the JavaScript APIs, and that's what Ted is going to be getting into a little bit to let you do advanced things in the browser, yeah? Let's do a couple more advanced examples, and then we'll talk about events. Couple more little ones, importing a couple of other fun functions from the DOM like document or alert. This is an example of using the Python function that should be callable. Is callable is a holdover. Callable is a Python function that tells you whether a thing is callable. It knows that the JavaScript function alert is a function. It knows that the JavaScript object document is not a function, right? So by and large, you really can treat JavaScript objects like Python objects. It's very cool. Under the hood, what's happening is they are being proxied, right? There's essentially a proxy layer that lives between Python and JavaScript that's handling the things that don't quite line up between the two languages. I mention this mostly because if you see in your error messages something about a JS proxy, now you'll know what the heck is going on, right? There is some object you have grabbed out of JavaScript that is behaving like a JavaScript object, and we're asking it to do a Pythonic thing that it is incompatible with. A lot of those incompatibilities have been eliminated, but when you see JS proxy in your error messages, now you know what that's actually referring to. A couple of advanced examples here, and then I'll share a couple links that you can pull up on PyScript.com and try for yourself. Because we can import not just any object that already exists in any browser's global namespace, but any JavaScript objects that we put there, we can do things like put any JavaScript front-end library into Python. I'm going to pull this example up on PyScript.com, but it's very cool. What's happening here, and again, don't bother to squint and read the text at the top of the page. I'm pulling in the Xdata spreadsheet package from NPM, the Node Package Manager, which does JavaScript package distribution. I'm just pulling that into my web page, and then I can just import it as a Python object, call its constructor, and start messing with it, right, with no JavaScript involved. And that creates using this JavaScript library that someone spent a lot of time on to make a spreadsheet work in the browser, now we get to interact with it in Python. Let me pull that up here where I've hidden it. Where are you? So this is running in PyScript.com. I'm not going to share you the link, and I will show you why in a moment. But you can get the gist of the code here. Is that we just imported our X spreadsheet object into Python. We've imported a little extra part of the py.ffi. There are methods of basically if you want to unwrap that proxy and you need to deal with it in a more explicit way, there are APIs for that, right? Sometimes the magic isn't quite what you'd want it to be. In this case, converting a Python dictionary to a JavaScript object, which look very similar but are slightly different. Again, the specifics don't worry about. But what's happened here is just with these, I guess it's two lines of Python code, I've now basically made use of, I've been able to pull in a JavaScript front-end library and use it with Python, which is cool. That's the gist of the interop here, is that we get to, as Pythonistas, now start to make use of JavaScript front-end libraries, which I think is a lot of fun. The reason I will say I'm not sharing the link to this one is if I open, did we say we can do this, by the way? You can open these links, these pages, these apps in their own pages. If you go to the Open the New Tab button, you get a link to the web page that is your PyScript.com app. And this link is public on the internet right now. Like you can text this to your grandmother and she can open this app, right? It's pretty cool. The reason this is failing, I'm now getting a name error about JS. The reason this is failing is because of what's called cores, which is limitations on where your web page can and can't load certain bits of code from. This bit of code I'm loading in an unsafe way. So while it's working in this sort of sandbox environment of PyScript.com, it'll break if I send you this link. So apologies. That's another thing you get to contend with as burgeoning web developers, right? Is cores.
Run, copy the URL. Run.
What? Yeah, see if you can give me quickly.
Take a picture.
Here, I think I have some later examples that'll be, that have some more interactivity. I know that was real fast, and like I said, Ted's getting into this more later. Questions?
To work around that, would you be able to just download the JavaScript file into your local website and post it with your files and it would work?
Probably, unless it's doing something that requires advanced permissions. There, I think, as Ted mentioned earlier, there's some things that browser will only let you do in a sort of secure environment. PyScript.com is fairly secure. But I don't actually know for this one in this case. But hosting it yourself would be a great place to start. Yeah. Other questions?
A note on this one. Some of the course configurations depend also on the server that is serving them. It's not only to the end user. So sometimes you have actually to do something like download your image or your assets or whatnot and have serve on your own domain. Basically the same domain that you're serving your app from.
So, I mean, one of the things, I was looking around in people's faces when Jeff was demoing, and there was a lot of when you saw a bit of JavaScript being called from Python and what have you. So you're getting some really wonderful stuff from the world of JavaScript and the web. But at the same time, you get all the really rubbish stuff from JavaScript and the web as well, like, of course, cross-origin resource sharing, things like that. So you have to start to become develop a spidey sense to figure out this isn't really a Python problem, this is a browser problem. The browser is doing certain things in a certain way that might not be quite how you're used to when you're using Python, say, really locally on your laptop. So it's a fun place to be, I can tell you that.
It's not boring, that's for sure. Awesome. So that's the very basics of JavaScript and Python interconnectivity. And like I say, we'll talk more about JavaScript and its possibilities in a little bit. I do want to pick apart a little thing that Nicholas said earlier, which is also very cool, and talk about events in the browser. So here's another piece of that sample code from earlier in the day, right? Input, type equals text, ID equals English, pyclick equals trans brackets. We said this is the way that you hook up HTML to Python. And this is part of the PyScript API that allows us to sort of build responsive web pages, again, without resorting to JavaScript. right? So for those who have not worked in the browser before, and given the JavaScript level, I'm guessing most of you are relatively new to that, right? The gist of event reactive code is relatively straightforward. When something happens in the browser, we would like to run some code, right? That's really all it is. And that something happening could be the user clicks on something, or hovers over something, or an object gains or loses focus, or types, or they submit a file, basically any kind of user interaction you could imagine, and also a slew of others that happen sort of more behind the scenes. There are events that are triggered at certain phases of the page load lifecycle, when resources become available, when movie files are played to a certain point. If you can think of something happening in the browser, there's probably an event the browser is emitting that you can choose to hook into to let you do something when that happens, right? And we'll look at some more specifics in a little bit. This is a little tiny web page that I've hooked up to run events. In case anyone was unclear, I've hooked this up to respond to hover events, click events, type events, right? This is a web page, basically, right? When you type into a search bar and it auto-completes, it's listening for you to type. It's firing some code that's processing what you type and doing something, right? Responsive code, right? We get that idea. In PyScript, we have two primary ways of hooking ourselves up to react to events. I have a sneak peek of a future API that's adding some more cool ways. The first is handling code inside your HTML. This is what we saw earlier. This is what I like to think of as the event executor, because the argument is a string of executable code. So earlier when we wrote something like trans with brackets, or in this case pyclick equals say hi with brackets, we are actually writing there is a string of executable Python code. In a sense, we actually are calling exec on it. It's a little more complicated than that, but if you can write it as a contiguous Python string in there, it will be executed when the named event, that is after py in that case, is triggered on the element you've put it on, right? So we've used click a lot because clicking is a really easy thing to demo, but this could be pyfocus, pyhover. I think pyMouseover is the actual name of that one. PyBlur, which is when something loses focus, PyOnload, things like that. So any name of an event in the browser, and again, we'll dive deeper into the browser APIs, you can put after Py, and it will run that string of Python code in the global namespace, in Python's global namespace, when that event happens. Yeah, I know there was some questions there about, like, is this the name of a callable, or is this why do I need the brackets? We are literally calling exec on your code when that event happens, right? Which lets us do some more advanced things. I put a little demo here. So you really believe me that when you click a button, things happen. Yeah?
Is JavaScript involved in this process at all, or is this?
Yes. The short answer is yes. The way that we are doing the original hookup of the events to Python is going through JavaScript. Basically, pyclick in this case is shorthand for PyScript to do to add an event listener, listening to click, and adding this piece of code. Yeah. So the users, you shouldn't have to type any JavaScript, but under the hood, yeah, for sure. Good question. Yeah.
Does the registration happen on page load, or is it dynamically added on and that has a pyclick handler with that one?
It's such a good question. The answer right now is it happens on page load. We are moving forward to allow that to be dynamic. The problem is it's expensive, right? Where the browser has facility built in to watch its own event handlers and manage when you reassign its internal attributes. PyScript would install what's called a mutation observer, basically watch the entire page, and whenever anything changes, see if one of the things that changed was like a pyclick attribute, right? So it's just a little bit expensive to do, so we have to figure out really, like, is that on by default? Is that off by default? Is it configurable? Like, it's an implementation thing. So, good question.
How terrified should I be that, this is arbitrary code execution by design?
Yeah, another good question, and one that we've talked about actually at length. Here's my pitch, since I have the microphone, but someone who comes after me can say something else. So it sounds scary when you can call exec on a piece of code. That's not a thing we want to allow users to do, right? Two things. One, all of this code runs in the user's browser. It's not running on on the PyScript.com or your local server at all, right? So in some sense, you are as sandboxed as you can be from being separate by it. The other thing I would say is, if this is a call to exec, well, this is basically a call to exec. You put some code inside a PyScript tag, we will run it. PyScript will run it, PyDie will run it. So I don't think it's any more unsafe than putting it in a PyScript tag. That said, when we get to the future-looking part, we are breaking this down a little bit. Yeah, fair question. Yeah.
So I was thinking about that, we're talking about a security standpoint.
Yeah.
But the user's not typing say hi. That's in your code.
Correct.
To do when the user does
Yes. Yeah.
User's not actually, you haven't opened up a security access for the user.
Correct. There's no, I think, and I'm not a web security expert, and there probably are those in this building who are, I don't think that this is any more insecure than the fact that we got a JavaScript REPL in the browser already, right? Anything you can do to your own client window, this could do, but no more, if that sort of makes sense.
That is, yeah,
That
that's the
fair?
answer, basically.
Yeah.
That you should expect the same levels of security that you have with your baseline browser.
Yeah.
That no more, no less.
Yeah. Yeah.
I mean, somebody could open the code in their browser and alter it.
For sure. For sure. Just like any other front-end JavaScript, right? If you,
It's their browser.
it's their browser, right? If you want to go like view source on Facebook right now and change the code and make it green, nothing's stopping you, but it won't affect anybody else, right? Same thing here. It's a front-end framework.
That's a powerful thing as well. Your sandboxed browsers have been around for, 30 years. So they're very mature when it comes to making sure that when you're sandboxed, you're really sandboxed.
Yeah, now, the trend, like,
Here, have a little-
opinion, yeah. Gut feeling is that the trend is that the browser is becoming more closer and closer to your operating system. Like Chrome actually enables you to allow applications to access your file system explicitly, not implicitly. You need to give permissions and stuff, but it's possible. So in the future, I think things are going to be closer and closer where you will have a level of permission where you can allow browser applications to access things, but I would assume everything is going to be super controlled. The browser is a very secure virtual machine, to be honest.
As is WebAssembly, from my understanding. And Antonio's talk tomorrow on WebAssembly would be the place to hear about that. But that is designed to be a sandbox, right? So breaking outside of WebAssembly and then breaking outside of the browser, right? We're no less secure than those two layers. One more little demo just to demonstrate, like, we are really calling exec on this code instead of eval. It's a little more complicated than that, right? But you can write multi-line code in here if you want to. I would say this is maybe not the cleanest thing to put in your HTML. This is the use case that I use most, right? If I know I might need to call a user function, I might throw an import in front of it, right? So I can do import OS and then print os.get current working directory, right? And if I do that, what I actually see, and this is something that was referenced earlier, is not the working directory where this is being served from on my computer, right? This is a presentation running on my laptop here, not PyScript.com, but the current working directory inside the virtual machine, the inscripted virtual file system that is surrounding the CPython runtime in a browser in the way. We get a lot of security reports of people saying things like, I ran, get current working directory and I can see my file system. What you're seeing is a file system that exists only in memory and only inside of this web page. Right, that you can do things that require file access. You can write files to it. You can read files to it. The fetch configurations you looked at earlier are all about moving files in and out of it. That's, I guess, a deeper level of this demo. This demo is just meant to say you can do multi-line things because we're using exec and not eval.
Will this demo break if you remove the semicolon?
I don't know. Let's find out. Do I have a copy of this in PyScript.com? I don't. When we hit our next break, which I think is after me, let's try it. Because I'm not sure. I put the break in there just for formatting in this page. I think it would run because JavaScript maintains white space in most scenarios. But let's find out. So that is the, if you want to set up your event handling and you want to do it on the HTML side of your code, this is essentially the syntax. Py dash the name of some event equals some string of executable code, right? If you want to do it inside of the Python, we have a way to do that too. And whether you want to do one or the other depends on what you want to do. It might depend on your code organization, right? If you have lots of things together in your HTML that act the same way, or lots of things in your Python functions that act the same way, maybe you'd want to do the setup in one piece of code or the other. When I said earlier that when something happens, we want to run a piece of code, it's slightly more involved than that. When something happens, we emit an event object, and when I say we, I mean the browser. The browser emits an event object that is given to our piece of code to use if we would like to. And these event objects are really useful, it turns out. The browser would love to tell you what it is doing. There's all kinds of events. This is about a third of them that are the most interesting and popular, I think. Things like events for when you focus on an object, when the mouse wheel is scrolled, when you submit a form to a website, that kind of thing. Basically, in the same vein of there's an event for everything, there's a subclass of event really for everything. All of these events have common attributes that are really useful to us. Things like target. So event.target will tell you the HTML element that it was dispatched from that we can grab. A timestamp in milliseconds from some origin. It's not UTC or anything, it's from page load maybe, but from a consistent time. IsTrusted is an interesting one. The event.isTrusted attribute tells you if you are handling an event that was triggered by a user input, and if you are, there's certain things the browser will allow you to do that it won't do otherwise. Right? In JavaScript, you can tell the computer to run some JavaScript code that clicks on a link to a new web page and takes you somewhere else, which is a scary thing for your code to be able to do. But it's only allowed to do that if it's responding to an event that is caused by user input. Right? So you can't go to Facebook and have it automatically redirect you to MySpace. The redirect click action has to happen in response to your user input. Right? These are really parts of the web API, but I want to introduce them as the idea of talking about events. And then the specific events have specific attributes that are useful to the specific kind of event that they are. For example, the keyboard event has things like the key code attribute, the index of the key that you pressed. I can tell what key I pressed by listening to key code, whether there were any modifier keys pressed, whether we are automatically repeating a character because we're holding down the Z key and we're hitting Z, Z, Z over again, right? The browser loves to tell you what it's doing so you can do useful things with it, right? The way that we in PyScript respond to this is with a function called add_event_listener, add_event_listener. That is part of the Pyodide FFI. It's a thing that we get from Pyodide, and there is a workable demo for this in just a moment. The API for it takes an element from the DOM, which we saw a preview of how we grab that, right? We import from JS, and then we do document.get element by ID, or get all the elements, right? We get a reference to an element, the name of the event we'd like to have, and then we point it at some callable we'd like to call, right? So finally, we've gotten to the workable demos. If you want to run this one locally, if you go to tinyurl.com/add_event_listener, all one word, that is a link to the PyScript.com app for this demo. It will take you to the live version of the app. If you click on the view code version in the bottom right corner of the page, you can view it live. But just to walk you through the code that's up here, what we are doing is importing the couple of bits of function that we'll need. We'll import JS, which is a reference to JavaScript, and from the Pyodide FFI, so from pyodide.ffi.wrappers, import add_event_listener. I'll define my event that I might like to run, say hi. It's going to print out the event that it gets. And then down here, I will grab a reference to the element that I need, js.document.getElementById, my button, which is the same as the ID up here. And then I will call add_event_listener. I'll give it the button, the kind of event I'm interested in listening to, and the name of the callable that I'm interested in calling. Right? In this case, I'm passing a reference to that function into the add_event_listener function. Yeah. If I come down to the live demo, which thankfully still has the URL on it, which is quite good, we can tell this button is, it says triggered by object pointer event, right? It's being passed a JavaScript object, which is a pointer event, mouse event, right? A click event, essentially. And it's printing that out to the screen for us. A couple more demos, and then we'll get a break and we can play a little bit. But any questions so far? Yeah?
Tell me if you don't want to answer this right now.
I might.
This is a Reveal.js presentation that's actually running.
Yeah.
How did you do that?
Yeah. So the candid answer is I'm cheating a little bit. The PyScript that's running under this page is a lot more than what you see on the screen to make the formatting work out correctly. You can just run PyScript on a web page, but to make it appear in this nice box and scroll, this implementation is running the gist of this code and then a bunch more stuff to make the formatting good, is the truth. So yes, PyScript, not just this much PyScript. Yeah. Other questions? Cool. Let's do one more example. This one, if you want to view the live demo of, you can go to tinyurl.com/pyconvalidate, all one word. I'll take you to the live demo of this. Just some slightly more involved ways of working with this event object rather than just printing it out. So the same thing, we're importing our couple of objects we need to work with. We'll define our function, which takes in that event object. And all it says is if pi, the string pi, is in event.target.value. So event is the event object. Target is the HTML element it came from, right? What's triggering this event. If its value, which is the value of user input, contains the letters py, we'll set the color of it to green, otherwise make the color of it red. And then we'll do the same two things where we grab a reference to the input on our page, and we'll add our event listener with that reference, the name of the event we want to use, in this case input, which fires anytime the input changes, and the reference to our function. I have spare quotes here, but I think I have actually fixed that in my live demo. So if I type hello PyCon, we can see when the input contains py, the validate function is turning our the style element, the style.color of our input green. If it does not contain py, it makes it red. And that event is being triggered anytime the value of my function changes. That's the definition of this input event. So anytime I type something new, I'm basically running this validate function, and in real time it's changing the style attribute of this input, right? So a slightly more advanced example of what's going on there. Now, I will just mention there's also a remove event listener, because it would be pretty rude for us to not clean up after ourselves. So if you're doing a more advanced functionality where you need to be actively managing what has and doesn't have an event listener, you could keep track, like a list or an array or something of your event listeners, add them or remove them as you see fit. Okay, how are we on time? Am I going way over? A little bit? All right, real quick. Let's talk about what's coming up next. So this is things you cannot demo today, but I think are exciting. This is the current syntax I just showed you, right? We define a callable, we grab a reference to it, we use add event listener to add an event listener to this object, right? But we in Python actually already sort of have a syntax for when we want to take a reference to a callable and modify how it works, right? If we are writing a function, we say, I have this behavior for this function, and sort of separate from the behavior of the function, I want to define the context in which it runs or add some behavior to it. And that syntax is a decorator, right? So we're adding the @when decorator to PyScript. This will be, I believe, in the next release, which essentially is, yeah, it's just a simpler way of writing the same thing. You decorate the function you want to call with @when, pass it an ID of an element in the DOM, and the name of the attribute, and it will do the hookup behind the scenes for you, right? These two pieces of code at the bottom are doing exactly the same thing. One's just a little bit more Pythonic, right? So we're trying to build this API out away from sort of the JavaScript way of thinking and use the Python features where we can. So things like that. Please, yeah.
Quick survey. Who thinks this one is better than the other one?
Okay, so we should merge this PR is what I'm hearing.
For those who think it's not better, why?
Ooh. Brave souls.
Or during the break, if you think it's not better, come talk to us.
Yeah.
Because we want to do, the most Pythonic thing we can.
For sure. We don't need to necessarily go through the full definition of it, but it's like I say, it takes the name of an event and the name of an ID and does the hookup behind the scenes for you with a slightly cleaner syntax. And like I say, this is not live on PyScript.com yet. It's a good time to say PyScript is, if you might have guessed, is changing really fast. So every new release is a major release in a sense. So keep up to date with the docs and the APIs and the changelog and all that. Oh, and a voice in my ear is saying pin your releases. Yes. So we do have functionality in, if you go to a PyScript.com app, you'll see it is pinned to pyscript.net/releases/2023.03.1, right, which is the current pinned release. We do also have links to things like /latest. If you need to do some quick testing, I encourage you to deviate toward a pinned release, because if you do /latest, then when we do our next release, we break your code. I guarantee it. So pin your releases to a current release if you have a chance. Yeah. So let me open up a PyScript.com app here. In index.html, slide this over. Up in the head section of the HTML document, these two lines are what we're looking at here. The lower one, script defer source equals pyscript.net/releases/2023.01.1/pyscript.js. That's pointing to the PyScript JavaScript library that's driving all this behavior. So you'll see, especially in some of our earlier docs, you would see things like /latest. Currently, that's 2023.03.1, but when we do a next release, it won't be anymore, right? So your power is yours. Same thing with this CSS file that's in this head here. The CSS that's there does a little bit of cleanup around how the PyScript tags are formatted before PyScript loads, how the REPL loads, things like that. It's not a huge amount of CSS, but if you're building this on your own, that's another thing to copy. Good question. This goes back to what you asked earlier. We're allowing users to exec a whole string of code. We're actually moving away from that syntax in future versions, probably to have things that are just an eval statement instead of a full exec statement, right? A expression instead of a whole string of code. Just because we want to encourage coding style where users should be putting their behavior into functions or into other encapsulated things instead of writing their entire Python file inside the HTML like PyClick attribute. So more changes coming. Pin your releases so we don't break your code in the PR. Okay. A lot of things. Yeah, we'll skip past that because it's not in the current release. Questions? None here. Great. How are we on time, Ted? Cool. Are we due? Is the thing it's time for a little break? Great. Someone who has the calendar for how long are we breaking for? It's 3:15. Say back at 3:30. 3:30. We'll hang around and answer questions. Be back at 3:30.
All right, so let's restart after the break. Hope you got your coffee. And we'll talk about plugins. So actually, before I talk about plugins, I wanted to mention one thing. Earlier, Madhur mentioned you can add different interpreters like MicroPython instead of Pyodide. That is, while it's true that you can change versions of Pyodide, MicroPython right now is in experiment mode. You can't really use MicroPython today, but we're pretty sure with the next release it's going to be available. We do have some demos and proofs of concept with it, and we'll be demoing during our talks as well. I think Nicholas is going to do it at his talk. I'm gonna demo it at my talk as well. But just keep that in mind. So plugins. Let me start with a quote, which was more or less like, the system built on top of plugins from start is often an indication of engineers who don't know what they're doing or what they're going to build. So instead of working through the hard process of understanding, etc., what is the final goal, they implement a plugin so that they can change things later, which not a great thing, especially coming from your boss. And the CEO of your company. So, but in our defense, PyScript was designed around plugins because we kind of knew what we're doing. Python on the web is a very different and new ground, and the vision is actually to enable, as Ted mentioned, to enable frameworks on top of it. And we want it to be a thing that people can create new projects, create new frameworks, and allow others to think differently. So in that sense, we wanted to make sure that it's pluggable and easy to change later. So let's talk a little about platform versus a framework. Anyone knows what's the difference? Or what do you think is the difference? All right, so we're using those terms as a framework is a type of software that allows you to write applications with that technology. A platform is a piece of software that allows you to build frameworks on top of it. So the idea is that with PyScript, well, you can create applications, but we also want to make it very easy for you to create frameworks that others can use to create their own applications. In fact, I'll show later, but this slideshow is using a bunch of plugins to increase capabilities. In fact, I'm a little disappointed by everyone else who didn't use PyScript itself for their presentations, but used Google Slides, but that's fine. So, as I mentioned, we are kind of exploring unknown waters, and a lot of those things may change in the future. And by taking specific choices, like designing a plugin API, a pluggable system from the beginning, by highly encouraging people to pin their versions of PyScript and dependencies and things like this. We want to try and make it more stable as we go, right? Also, we're trying to make the plugins API quite stable and quite flexible in terms of how it hooks into the PyScript lifecycle and other things. But piece of warning, we're still very early on. So let's talk about PyScript plugins. As I mentioned 2 seconds ago, the API is changing or is likely to change. So if you're using plugins or you're writing plugins, highly encourage you to pin your PyScript versions and your packages versions. Which, by the way, even without PyScript, if you're just writing vanilla Python, pin your versions. Like, this is just a best practice that you should always do, because usually it's Friday afternoon, you're about to go home, and something breaks. Half of the times, in my experience, it was because of a version that was not pinned. So let's first look at how to use plugins, right, as a user. As Madhur showed earlier, basically all you need to do is to add your plugin to your list of plugins in your TOML file. Now, what's the difference between a plugin and a package? Not a whole lot, to be honest. But we chose to be explicit about calling plugins as plugins and not as packages, because they can be, on one side, way more simple. It's just a text file that we consume over the internet, or it can be a much more complex thing with JavaScript assets, with images, with sounds and whatnot. So we wanted to have the freedom to support other types of formats and things like this in the future. So in the spirit of explicit is better than implicit, we wanted to make this way. But you could eventually also write plugins with the Python package, inside a Python package, which I don't recommend. Anyway, that's it. You add that to your TOML, and you can now enjoy your plugins, right? So let me show you an example. This whole presentation is using Markdown, and it's a plugin. So I added my PyMarkdown plugin as in the list in the TOML, and now if I write this, it translates to this. And this is live code running inside the presentation itself, right? Any questions so far? Mm-hmm. Yes, but I have the same issue that Jeff has.
Cheating a little.
Well, basically, because of course, which Nicolas said, by mistake, it actually it means, come on, really? Sucks. But it's because it ties to the security topic that we mentioned earlier, right? Like, in reality, we all blame it, and it sucks. But for a lot of times, it's for good reasons. Anyway, because of that, I need to change a couple of things. But yes, I'll have it ready. I will tweet probably in the next day or two. And I actually will show the code as well. So this is another example of another plugin that actually is being used in all our examples in the website. And this is called PyTutor. And what it does is you can add the PyTutor tag to your HTML code, and it documents everything that is within those tags. So to see the code that is behind this, it adds a button here. If I click, I can see the code itself. And this is another example of composability in PyScript. So for instance, this slideshow is made with PyPicard, which is another type of plugin on top of PyScript, that is using the Markdown plugin. And inside the presentation itself, I have an iframe that is serving a PyScript application that is on another website, which, it's a lot of boxes inside boxes. But this is one of the things that we try to make explicit from the beginning, because coding should be fun and should be a lot of experimentation. And if people want to compose pieces and put them together, pretty much like Lego blocks, we should allow them, right? So that's the spirit. So how does it work? We expose plugins API that allows users to write Python and JavaScript plugins. It exposes hooks for plugins to basically intercept events in the PyScript lifecycle. So for instance, when the interpreter is loaded, or the packages have been loaded, or when we parse the TOML, all those things, so that plugins can change those things or do whatever and whatever they need. Also, the plugins API allows you to create custom elements. Who here knows what a custom element or a custom element is? Or a web component? Cool. Basically, they are often used to mean the same thing. It's a way to extend the HTML domain with new tags that have different behaviors, right? So the PyScript tag is a custom element that adds the PyScript tag to your page. So plugins can, as I mentioned, can be either Python or JavaScript, and they can use Python packages or JavaScript packages. And they can load things in the page, or they can just load in the Python interpreter or the JavaScript interpreter itself. Another thing to mention is a bunch of core functionality in PyScript are written using plugins as well. So the terminal, for instance, that you see the logs from the Python interpreter, that is a plugin itself that is just served with the whole package. As I mentioned, plugins are different than modules, but oftentimes they overlap in functionality. So those are the nice things about plugins. It also has a bunch of not great things at the moment. They're not complete yet. So we didn't map all the lifecycle events to API hooks yet. Both for I think for JavaScript, almost all of them are exposed. For Python, not all of them. And even when we complete the Python events, we're not going to have the same number of hooks in Python that we have in JavaScript, because Python takes some time to load, and a lot of things happen before that happens. So JavaScript is already ready in your browser, so we can intercept a lot of events. Python plugins are going to accept hooks only when the interpreter has loaded. Hopefully it makes sense. Also, the custom elements allow you to connect to DOM events. So for instance, when the Py Markdown tag, it loads when the browser sends a connected signal to the class itself. Basically, when it connects or puts your tag in the DOM, that function is called. So that's the only one that we connected right now. So for instance, if you resize your browser, that is another event that I think it's called resize. That is not mapped right now. You can manually do it, but we want to provide APIs for you to do automatically. Also, another thing that is missing is Python and JavaScript plugins should be able to declare their dependencies. So for instance, the Markdown plugin depends on the Markdown package, the Python Markdown package. Right now, I have to add it explicitly. In the future, it should just work. So we covered how to use a plugin. Now let's see how to create a plugin. This is the Python code for a simple Hello World plugin. All you need to do is to import a plugin class, declare here, and then to create a custom element, we have decorator that allows you to decorate a class and say, hey, use this class creating this new tag, Python hello world, and then this is the method that executes exactly when the element is connected to the DOM. So in this case, it basically is just printing hello world inside a div. But you can think of a lot of creative ways to do it. Actually, I will show you the code for the Python Markdown as well. Another thing to mention, right now, JavaScript plugins are mainly internal only. We exposed them with the latest release, so you can actually use it, but they're not documented yet. And it's explicit reasons we wanted to wait until we get a few things sorted, but they're most likely to be officially exposed and supported in the next release. Question?
Yeah, can you clarify if the intent is, and say this, I have definitely been flummoxed before by things that interface between Python and JavaScript that made me understand too much JavaScript.
Mm-hmm.
Is the goal here to enable it only if you have to, or do you really sort of treat them as equal players?
Great question. So the question was, is the goal here to support JavaScript only if you really need to and try to give as much functionality on the Python side as possible, right? And yes, we wanted to make sure, like, I would want everyone to just do Python plugins if they can. There are a few caveats. For specific things, JavaScript plugins are going to be more performant because of loading time, because of just decades of JavaScript being native to the browser and things like that. And also, if you need to do specific things before the interpreter has loaded, or you can't allow yourself a significant loading time, then you will have to do JavaScript plugins. But on the second case, as soon as we officially support MicroPython, I think a lot of those cases will drop because it's blazing fast, and so that will be a good thing too. Another thing worth mentioning is that the JavaScript interface, FFI interface between Python and JavaScript is only available on Pyodide. We are currently working with the two projects to create a generic interface that could work at the PyScript level, and we will allow you to just use the same interface for both interpreters and without problems. The same work is also going to enable you to run code inside web workers that will allow faster execution, will allow actually you to block code, which means I can have a debugger now, which means I have parallel tasks and other things like this. Nicholas, you wanted to say?
Yeah, so Fabio mentioned ongoing work with MicroPython and Pyodide about the FFI. We've got basically working code, and it's early stages for MicroPython, but it's there. It's not like, could we do it? Well, yes, it's kind of been done. We now need to refine that and check it and test it and blah, 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 which is itself as we know kind of a significant amount of work. But the point is that it works. I was using it yesterday.
Great. So I had the link to the official documentation here, but I'm basically done with the content that I wanted to show. There is a full section about plugins in the PyScript documentation, so I would suggest to check there. And I wanted to show you all a couple of things. So this is actually the code for the presentation itself, right? This is the code for the PyMarkdown plugin, which is not a whole lot. And this is basically here just to show how to hook into lifecycle events. It's not really needed. Oh, yes. Thank you for reminding me. So this code here creates the plugin class. You don't need those, really. You could just use the plugin directly. But this shows you how to hook into the configure event. So basically, as soon as we parse the TOML and the configuration of your environment is done, this method is being called. And right after we set up a whole environment and the Python interpreter, this event is being called. And then the rest is just, as I showed it before, we are registering a markdown tag, which is this one. And inside here, I'm using the markdown module and the HTML module, this and this, to get the HTML inside the PyMD tag and unscape the content because it's the web and everything is escaped. And then here, use Markdown to parse it and generate HTML for us. The other thing I wanted to show is why I'm not, the other thing as well. As you can see, this is the whole code for the presentation. Everything I showed you. So yes, Review.js is way more mature, has animations, have support for a lot of things. But if you look at the code for a presentation, it's a lot of files, a lot of JavaScript files, a lot of things. We will be adding more features, but we really want to make sure that as we develop supported frameworks like PyperCard or PyScript itself, we want to keep it simple, right? I'm doing the whole presentation with just a CSS file and the PyperCard framework, which is just those 4 files, basically. Everything is in here. I'm not sure I'm having internet issues, but anyway. And as you can see, it works just fine. I have another demo, but I will do right after that. Otherwise, questions? All right. Ted. Oh, sorry, I haven't seen. Yes, I'll share this. Yeah, I can also I can share the link already. Just know that the 2 wireframes are not going to show, but the rest of the presentation and everything else can be used already.
I mean, I like to go home and do a presentation at work using.
Yes. Yeah. Nicholas is probably looking at me and saying, "What are you doing?" PyperCard is very alpha also, so keep that in mind.
But here's another aspect of this. Imagine you're a teacher and trying to get Python installed on machines in your school lab is, you might as well, I don't know, stick forks in your eyes or rub a cheese grater up and down your nose. That's how much fun it is for a teacher to try and do that, okay? All of a sudden, and if you've got a presentation, your pedagogical tool is something like PowerPoint, and now you've got a presentation tool that is both written in Python and you can use to express Python and demonstrate Python, then that's a very compelling story for the education sector.
Yeah, we've been trying to look at students, educators. Education is a big target for us. Also, like the same thing, think about presentations where you can show your data and you interact with your data, and you're not just looking at static images, but you're actually querying stuff and you're displaying live data, and you can run models and all those sorts of things. We want to create new ways of just displaying data or interacting with your applications and whatnot. And plugins is in that direction. Just bots that you can run and experiment with.
Cool. This is actually my first PyCon. And I started using Python it was 99, version 1.5.2. And I've used it on the server side a lot. But if you were to ask me what I do normally, I'm sort of TypeScript, JavaScript native. That's the world I've lived in for the past decade. And so this project for me is kind of returning back to my Python is improving. I think I can pretty confidently say that's happening at a rapid pace. But what I want to show you is I want to talk about the browser's APIs as an additional standard library that you have access to that is not in the Python standard library. This is a different environment, and you can take full advantage of the browser, and the browser does amazing things. It has some APIs that are hard to understand, but PyScript gives you full access to those. And so I want to take you through what that means, how you can use those to your advantage, and then I'm going to take you on a tour of those. There is a URL in the corner of this slide. If you open that, you will get a list of all the examples that I'm going to show you. And in the bottom right-hand corner, there is a View Code button that allows you to copy them into your PyScript.com hole. So please bookmark that URL, and you'll be able to take any of these examples and kind of run with it. As Jeff discussed, the JS module is a direct mapping with kind of some light Pythonic translation to the default global this object of the browser window. And global this is the global object upon which every page is loaded. So anytime you load a web page, you get a brand new global this, and the browser basically exposes, based on the domain that you're on, exposes these APIs for you to take advantage of. Depending on the state of that URL, certain things are exposed. So if you're not on HTTPS, there's functionality that the browser truncates. So the standard library of the browser changes contextually based on where you are, how the domain was set up, how the security policy of the domain was set up, and the like. There's lots of documentation on it. I'll show you the best place to go, which is really the Mozilla docs. They're fantastic in the sense that every API that I'm going to show you today is very, very well documented on the web, on the Mozilla docs. And so in this particular case, if you wanted to access console log, console debug, console, there's a ton of objects inside of console, you can simply call js.console log. And that API allows you to write to the console. So it's not a print statement. The output is not going to go to the DOM, the way PyScript enables. Oh, that's my alarm to pick up my son today. Apologies. There we go. Reality strikes.
Call your wife because your son is going to be waiting.
There's a little boy somewhere waiting for his daddy.
Daddy's presenting. Okay, so console log allows you to log things, and you can log objects, you can log any type of data you want. And actually, in this case, you can actually inspect some of the items kind of behind the scenes. If you open up your console in the browser, you can basically see this console log and what gets emitted. But one of the handier things is being able to actually grab a reference to an item that is in the DOM and basically then begin manipulating it. So in this case, js.document.getElementID, that will return a reference to the node in the browser that is denoted by ID equals myDiv. And so using IDs is a pretty standard way to do selectors and bring data back. But once you have that, you can do interesting things with it, like write to it. You can modify its data. You can change its state. And you can do this at any point in time. And so these APIs are important because you're working in the browser. PyScript is inside of the browser runtime, and all of this is accessible to you. Additionally, the import.js module actually is writable. So if you write data to it, JavaScript has access to that data as well. So this is bidirectional. You can, in this last example, js.foo equals 1234, there is an integer sitting in the global space that you can pull from JavaScript and read. So this isn't a one-way street where everything's jailed into Python. You actually can go back and forth and do interesting things across those boundaries. And because of the way that the FFI was written, those objects are manipulatable in Python directly. And I'm going to show you a couple examples of that. So first thing I'm going to do, I'm going to open this URL. And I'm going to zoom in a bit. Yes, the foreign function interface. There's actually two of them. There's one from JavaScript to Python, and there's one from Python to JavaScript. It's basically how do you call from inside of Python out to JavaScript, and how do you call from JavaScript into Python. And that is part of the Pyodide project, although much of that is actually being ported and moved additionally to the MicroPython runtime. So we're going to try to do this with both runtimes in an elegant way. So the first place I'd like to take you is the docs. This is absolutely the best documentation on the web that exists. Use it. Please don't go to the other sites. If you W3 schools, I know I'm not, I would strongly recommend going to Mozilla Docs. Whenever you see it, click on a Mozilla Docs link and you'll get information about what you need. Now inside of this, there are some interesting APIs. Well, I can get the battery status of any device. I can tell when the battery's low from a web page. And it's especially valuable on mobile if you have a mobile app and you're running into low network conditions and you can actually query and show what the battery meter is. And these are accessible through the Navigator object, but Navigator is just javascript.navigator. And in the JS global object, the namespace is not Pythonically, it's not snake case. It actually uses camel case. So anytime you're in here, all of the API names are camel cased. There's one exception that you need to understand. There is no new constructor in Python, but there is in JavaScript. And to access that keyword, you basically go to the end of the name and you tack on .new. You call a new method on the end of it. That will simulate the JS constructor. So if you run into it, you're trying to create a particular object type, like a new date, you need to go JS, capital date, .new, call a function, and you'll get back a new date object. Yes?
So why do that instead of making it into a more Pythonic constructor?
It's a great question. I believe the intent was because it's dynamically generated, it's always accurate. And so the browser APIs have been in change for a long, long time. Browsers introduce new functionality. One example is Chrome actually just provided a release version of Web GPU. That actually allows you to tap the GPU of the local machine and to do some pretty interesting calculations on it, including ML, AI related training. You're actually able to tap into the GPU and do matrix, the complex calculations that only a GPU can use. And so for that API to work well, instead of us having to update Pyodide and PyScript to always be accurate, it's better to have that interface be dynamic and reflect what is actually there at runtime. So that interop basically is done in camel case. I guess we could translate it somewhat, but there are edges and inconsistencies, and there are things that would cause us to do more work. We'd rather expose the functionality and give you the benefits of being able to use it in its standardized kind of state. So if you copy any of the names that are in the JS object, you can look them up in Mozilla Docs and find out exactly what behavior you're going to get. Now there is some issues with object translation. A lot of the items that the standard library in the browser returns are actually JavaScript objects, and the current default for Pyodide is actually returning a JavaScript map, not a JavaScript object. You can modify that, and it's an ongoing debate, but there are edge cases here that you'll run into and be like, it just doesn't work. Well, it works. There's just some, it's kind of lost in translation in some areas. But there are ways around it.
Great. On that topic, why not have a Pythonic version of those APIs? One is also, the other side of it is also time. We didn't get to it yet, but the more the project matures, we were going to identify the APIs that people are using the most and makes more sense to make it Pythonic and expose, like maybe a module or something like this where you can have a Pythonic version of this. Like the element class that Jeff mentioned is one of those cases where we want to make something more Pythonic.
One last little thing on JS and Python interop there. a lot of it is the case where like Python has a keyword and JavaScript doesn't, or vice versa. For example, the array class, which is like Python's list in JavaScript, has a method .from. You pass it an iterable and it creates an array .from. You can't have a method called from in Python because from is a keyword in Python. Python has ways around as you put an underscore in front of it, right? So there are workarounds to these things that are built into the runtime, but there's a lot of edge cases like that.
Cool. I didn't know about from.
Oh yeah, that's new.
There we go. So I'm going to go into this selector API. And right now it's going to be a pretty boring example. It basically registers. But if I look at the code, and I can actually run this in my project. So you can copy this into your own project. It's very simple. And let me zoom in to make sure but this code is 2 lines. Essentially, query selector, I'm going to target a particular div, and then I'm going to take that node, I'm going to write to it via inner HTML, and I'm going to modify it. So at runtime, you can modify any DOM element. You grab a handle to it, and then you just set the inner HTML, inner text, and that DOM element has been modified. In this case, I'm wrapping it in strong, so it's bold, and the result here is target div here. It's very simple, but you can see how these begin to build, build up. This is the primary way that you'd have an application to show a new state of an application. You'd change the contents of a particular div, or you'd hide one div and show another one. So let's back up. So write to. This one is interesting because it basically goes through writing to all the different things within your app. Wow. Again.
I hope your son's okay.
I hope it's not your son calling. Dad, come pick me up.
So in this particular example, let me actually pull it up here. So I have write to, and if you go into write to, it's a fairly simple example, and I know the window here is hard to read, but from JS import console and document. So you can actually be really specific about which items you want to pull and use. In this case, I'm going to modify the JavaScript title of the document. So I'm actually modifying the head document of the title in the head of the document. And I can actually write to that. And if I open up this, let me see, I'll open it up in a tab. You can actually see, you see this, it actually changed hello via title. And so that's one way to write. The other way to write is to write to the console log. Another way to write is to actually use display. Display is an internal API for PyScript, and you can actually target display. You can have it, you can give it a target div to where it always writes its output to that. It's very handy if you're working with matplotlib and you end up with a plot and you want to actually render the plot somewhere. You just say display plot and then you pass the div reference to it and it'll just write to that target. Another one is the simple print statement. We're used to that. But this one, I'm going to create a new paragraph element. I'm going to write to its inner HTML, and then I'm actually going to take that new paragraph element that I've created and add it to the DOM. I'm going to append it. I'm going to append the child to the body object. And so now we're actually in memory creating an object, a p tag, a paragraph tag, and adding it to the DOM directly. So again, these are standard JavaScript APIs, but they're exposed in Python in an elegant way that allows you to do what you need to do. Let's go back here. This one is geolocation. So every browser has a geolocation API object. And when you access it, it basically will write the location. So in this particular case, it is giving me the lat long of exactly where I am on a network, on the network of this. Now, I'm not sure how they've wired this facility or where the internet goes from here, but this is probably the documented IP address of the router that this facility attaches to. So it can give you pretty decent geolocation. More or less, it's 11 meters. and it gives you the accuracy as an output, so it can kind of determine. Yes, Nicholas.
And if you're on a mobile,
Yes.
whatever it's called, satellites in the sky. GPS, thank you very much. I'm Jebo. You'll get it pretty accurate.
Yeah, and if you're on a VPN, you'll find out where your VPN is hosted. So again, it's just it's as accurate as the network that you're on. Mileage may vary, but this API is pretty easy to access. Let me pull up the example. Geolocation. So I'm going to import JS. I'm also going to import create proxy and 2JS. Jeff touched on those a bit, and the options, I'm basically going to set some options, enable high accuracy, a timeout of 500 or 5 seconds, and maximum age of 0. And then when the page loads, well, we have a function called success, and success yields the position arguments, and the position coordinates are there. And then this is that output that basically, an F string that basically prints the coordinates to the print statement. But in effect, this is the call: window navigator geolocation, get current position, and then you basically are having to create a proxy around the success function, and you're also creating a proxy around the error function, or the error method you created, and then you pass in the options. So you're giving it this context, and then depending on if the geolocation API resolves to a location, it will either give you success or it will give you error. So it works kind of both ways. But again, standard access to Navigator geolocation. Questions? Okay. So let me back up here. And the location API. So whenever you visit a website, the URL actually is broken down into a whole bunch of really distinct parts. And they're really interesting to understand. You need to know what protocol you're on. You need to understand what subdomain you're on, or what full domain. And then basically what path, but also if there are hash values, so anchor tag on the end, or if there are query string variables where question mark data. The location API allows you in the browser to just read these values, and you can make use of them to navigate the user to either the next page or back, or take that context and say, oh, they hit the back button, I need to load something. So you can actually key off the location object to determine where the browser actually is. Oh, that's wonderful. Let me see here. Let me pull open the example. And most of this is actually in the HTML. I think, yeah, this is part of it. So let me pull this over. So you can basically import JS, and the location is the document location. And then you can actually use the properties to walk all of those parts. And you can pull those attributes from the location object as needed and display them. So protocol, host, hostname, port, path name, search, hash, and origin. And it allows you to get all of those objects in a fairly interesting way. I think there actually is a REPL that has this in it. Yeah, there it is. And if I run the REPL, I basically get the protocol's HTTPS, the host is the subdomain of my PyScript.com account, the host name includes the full port. There was no port designated. Sometimes you can put :80 after the actual domain name. There's no search, there's no hash. But I could easily add that value and just say, if I ran, so put an anchor tag on it, and then if I actually run this again, so you can now see that it actually detects the change in the browser. So even anchor tag changes. If your anchor navigation between parts of your document, you actually can have those detect where in the app a user has clicked or what the context of that click was. So local storage. So local storage is actually, it's a bit of client-side disk that allows you to write data into the domain of the browser that you're on locally. So it's not cookies because it doesn't travel with the request, but JavaScript and now PyScript can access that API and read and write data. In this case, it read none, and then I wrote this value Tom to it, and then I deleted the value and then called it again. If I open this app up, and again, pardon the screen layout here. I think we have a touch of work to do. Okay, so local storage. And in effect, JavaScript.local storage get item my cat. Okay, it's just an arbitrary name of an object that's in local storage. So in this case, it's none because there's no value there. And then here, I'm going to do JavaScript local storage set item. I can actually set my cat equal to Tom. It now has a value. And if I print that value, that's where it obtains Tom. And then I can remove the item from that local storage. And then I can actually get the item again when the key doesn't exist. So I go none, Tom, none. Simple, but you can actually do some pretty amazing things with local storage. We've actually been storing the state for our PyScript assistants in local storage. So I'll show you. I'll run the demo in a little bit, maybe after Fabio goes. But it's a handy way if you're on a site and you need to store some data and you need to store it in a persistent state. You can actually store it on the subdomain of the user's machine, and it's a safe API. So let's see. Let's go back again. How are we doing on time? We've got about 40 minutes. We covered an example which was writing to the file system, and I wanted to talk a little bit about that. So Emscripten comes with a virtualized file system. That is, we package Pyodide. Pyodide is packaged on top of Emscripten, and Emscripten provides the Unix APIs to allow the WASM content to run effectively. It provides a file system, and you can read and write to that file system. And if you just using Python standard APIs, they're mapped to that file system automatically. So if I write data to the file system, I press this button, and then I read the data from that file system, I can actually store data now in the Emscripten file system. And these APIs are one-to-one with Python's file I/O. So file open, file write, read binary, all of those flags, it works exactly the same way. But that data is in the Emscripten file system. It isn't local to downloading the files, it's virtualized. And it's safe. There's no way to get access to that remotely. It's literally in memory. So security-wise, if you tie into the Emscripten file system, you can effectively write some Python data there, but you're virtualized into the virtualized environment, and there's nothing you can do to the local machine. But you can also access it from JavaScript as well. So I can write to the file system from JavaScript, and I can read from the Emscripten file system from JavaScript as well. So you have multiple ways of getting data into that virtualized file system. And if I showed you this example, it wouldn't surprise you to see what it actually says. In this particular case,
Does it survive
Yep.
closing the browser tab?
when you close the browser tab, that virtualized data is gone. So it is a really temporary file system. Local storage does persist across browser refreshes. The Emscripten file system is temporary based on the state, and that's where we load the Python standard library and actually execute the Python code.
So you can keep other tabs open, but the data goes away when you close that single tab.
That's correct. That's correct. It's temporary. So in this case, write to the file system is with open, there's my file name, write to, and then you use standard Python file write. And additionally, if I want to open it with read, I'm basically opening the file, that file path that I created, user-text, and I'm reading it. And this is simply outputting to display. Or it's trapping an exception the file wasn't found. Question? Yeah.
Is there a pathway either now or imagined in the future to be able to use the
I believe there is. I know Hood referenced it. I know you've done quite a bit of work with
There
it.
are different implementations. So MEMFS is the default one, but there are.
So there's different virtual file systems depending on which one is used in.
So the default one that comes with it is called MEMFS. So refers to memory. So that's in memory. But if you go to the mscript documentation, there are other implementations, and it should be possible to use the other ones as well.
Cool. Let's see. Let's back up here. And so you can access the camera, like, hi, yo. And so you actually can access the camera object. You can actually access the audio object. You can actually process audio. Web audio APIs allow you to mix. People have built some pretty interesting mixers and audio manipulation tools along these lines. This one actually allows you to capture photographs. So I can take actually pictures of this and kind of capture state. So I can actually capture images and basically move them. The code for this is actually, it's pretty simple. It's just, here's native access to the camera object from Python. And from a programming standpoint, like just having someone on a web browser accessing, if they have the camera, turning the camera on. There are some permission issues. I have permitted this in my camera allowed. So we wouldn't want to turn on a website. You don't want a website to turn on your camera without you permitting it. That would not be the best thing. And so there's a whole bunch of, this is actually where core security comes from. It's blocking bad actors who are coming from the web to your browser from doing things you don't want, like stealing cookies, stealing accounts, and cross-accessing APIs. And so those standards came about because of basically some hacking that was going on and the like. But there are good APIs for it, and it's pretty easy to work through those. Let me actually show you what this example looks like. Video to canvas. So in the HTML here, I'm going to create two objects. One is a video object. So that video object is set to autoplay. And then I have a canvas element. A canvas element is an image that is you can programmatically write to. So it has both 2D and 3D capabilities. This is actually how WebGL renders inside of the browser. It's also able to do 2D games and other things. It's the primary way to do graphics because the graphics are so fast. I spent 2 years working on actually text layout engine inside of Canvas. And so you can lay out text with kind of accuracy. It wasn't the greatest for selection, but we could actually simulate exactly what Adobe's InDesign product did as far as text. So I have two buttons, a video element and a canvas element. And then in Python, I'm getting references to those objects. So I get query selector, I query those IDs. And then I have a couple methods. I have camera click, so whenever you turn on the camera, this is actually creating a JavaScript object using the Python, like the new constructor. So this is how you'd actually create a JavaScript object in Python from scratch. This creates a raw JavaScript object. And then I'm adding two properties to it, .audio and .video. In this case, I don't want the audio to come through because the feedback loop on this microphone would be unbearable for everyone. And then I'm actually creating a stream. And in this case, I'm using the getUserMedia, targeting this media object I created, and pulling that value in. And then I'm setting the video source to be the stream. So this actually allows me to access the camera, and then I'm piping that into the video object. Does it make sense? It's sort of like patch cables. You're just taking the output of the camera and you're patching it into the video object. And then when I press a button, I'm going to take a snapshot of the video object and I'm going to push that to Canvas. So you can do some pretty interesting things. So in this case, I get the camera, I get the Canvas 2D context. I draw an image that's actually rendering the graphics from the video into the Canvas object. And then I'm actually able to turn it into a data URL and then render that data URL back to the DOM. So you can do some pretty interesting media juggling here. And those APIs are kind of browser standard. But again, PyScript has full access to them. And they're yours to take advantage of. If you find the web's doing something interesting, you want to tap into these new APIs, it's an easy way to create new UI and the like. Before I turn it over to Fabio, we've been working on a new tool set inside of PyScript.com, and I want to kind of take you through it. So this is the PyScript assistant, and it is actually tied to an LLM. And if I need to kind of back out a little bit. So actually, let me switch to a new project. So I'm going to say new project. And then I'm going to say, write me a FizzBuzz example. And it goes off and returns, drum roll, FizzBuzz. And you can use this in all of your next job interviews. And you essentially print that, and then I can run it, and you get FizzBuzz. Again, I didn't write any code. That is actually an LLM generating Python code for me on my behalf. And I can ask it pretty interesting questions. So if I took this, and then I pipe it back in and say, explain this code to me, and I put it in backticks, it will explain exactly what that Python code does in a fairly intelligent way. Additionally, it has, most LLMs don't have any context about PyScript because PyScript is new, and most LLMs and the data models that are there are trained back to like data on 2020. So in this case, who are the PyScript maintainers who do not work for Anaconda? Question mark. And Jeff Glass and Paul Leverett. There you are. So it actually allows you to query the documentation. One of the interesting ones is, what does pyconfig do? And so we ended up training it on our documentation. We ended up training it on 35 code examples. And we're trying to get it to where you can actually talk to the documentation and have the documentation talk back to you. And so you can get pretty interesting responses and kind of deeper than normal without having to know where the documentation is and kind of pick through code examples and the like. It's kind of fun. It's kind of strange, a little different. Yes. Yes. Not client side. Well, the API is server side. The calls are client side. So have to make sure it's clear. Yes.
Some other system is generating tokens.
That's correct. That's correct.
But it's free. It's free of cost.
No, this one is a paid feature. I don't want to get into it in the tutorial, but we do have paid. We're working on paid tiers, and part of the process of building out PyScript.com is maturing some of the things with permissions and the like. So this is early builds of us building features that are specific for certain types of users. So the plan is actually to put this in the Anaconda kind of tiers for Nucleus. And basically when you get into either the Pro or the Starter or Enterprise, you'd get access to a collection of features. It's just added value on those. But I don't want to feel like this is in any way, shape, or form salesy or the like. So, yeah, question.
Are you worried you will all be fired next year when this is actually working fully?
No. It's just going to make the developer. It's just going to make you like developer and understand. Yeah, it's fun. Yeah, question.
Have you shared the high-level project
Yeah.
for the web API?
Yes.
But it doesn't show the code for each one of the individual. Can you share those?
That's correct. If you actually click on the link in the bottom right-hand corner, so if I go to, shoot, I was presenting the whole time. If you go to any of these, so if you go to the destination and then down in the right-hand corner, click on View Code, view code will take you back into PyScript and give you the option to copy your project. So with one URL, you have a pool of examples that you can use, manipulate, change, learn, etc. Let me turn this back over to Fabio. Thank you very much.
Couple of demos just to show contextual to what Ted was showing, and then leave time for you all to experiment and ask questions, and while we are here so we can help.
So Ted was showing an example of using Canvas for having live video image feed. Just to show what you can actually do with the interoperability between Python and JavaScript. A shameless plug here, but you could go to the Pyrite blog, and there's this blog on rewriting the matplotlib rendering engine using the canvas element available in the browser. So whenever you call plt.plot, the underlying canvas element in the browser is doing the actual drawing beneath. So yeah, this is some work in 2019. You can read on it and have some performance comparisons. And yeah, so interesting space.
So I wasn't planning on showing this demo because it's still evolving. But since we're talking about web APIs and using JavaScript stuff, etc., it makes sense. It will be more polished, and I'll show a link that y'all can share, etc., at my talk on Saturday. So, but this is just a preview because it's contextual. So, I happen to have a Lego robot. As you can see, can you tell what it is? It's an egg, yes. And there are wheels, so it's an egg on wheels, which for Python packaging should be very relevant. But I'll show you. I'll put it here. Thank you. So this was actually, it started from a connection. Oh yeah, we are gonna turn it on. Actually, let me just flip it like this so we can see the heart starting. And
That Lego device is running MicroPython.
yes, this Lego device is running MicroPython. So thanks to connections from Nicholas, someone was like, yeah, we want to use PyScript to control Lego bots. And we're like, okay, where do we start? Like, I don't even know where to start. And they're like, well, it just works. What do you mean? So they shared with us a version, and basically this is using what Ted mentioned, the JavaScript API. I'll actually open this in a different tab. And without installing anything, I didn't install anything or whatnot. You can just connect it to your computer. It loads, and then say, okay, give me access to the serial port. This is using JavaScript APIs. I connect to it, and once it's connected, now I have access to a bunch of functionalities. This has a motor and things like this. So if I change the speed of the motor and say run motor, it's actually, as you can see now, you can see that it's an egg roll. It's more understandable. And I can stop the motor, run again, change speeds to a very fast spinning egg. I can read from the serial port, do other things, and I can actually get data from it. And for instance, this display plots and stuff, which has a bug. But let me see if I can, yeah. So this is speaking, so the person who sent us the code, Chris, which very thankful for the support, actually connected this to his solar panel. And this is the data that you see from his solar panel today, I think, whatever it is. And you can actually speed the motor according to the speed of, I can't appreciate because it's super fast, but it does like a, yeah, a little thing. Anyway, you can go crazy and connect your camera with this as well. And well, actually I'm not gonna demo this part because it's a surprise for the talk. Anyway, this is it. And this is pretty much to talk about the nature of what the things that we're very interested in, which is lowering the barrier to do crazy things, to experiment, and get the best out of both worlds, Python and JavaScript, putting a nice interface to it. Now we have 20 minutes, and I want to make sure that you have time to ask questions and play with it, ask questions to us. We're going to be around and to help you.
So just to make sure this device is clear, it allows you to take pens and color the egg as it's being spun. And it's been designed for kids. This actual one was at the White House egg roll probably 2 weeks ago at Easter, and there was a line of kids. The line it said 50 deep almost the entire time that the item was going. But it allows kids to programmatically just...
because it's connected, it's not working.
No, it doesn't.
Yeah.
But you can press this button and
Yeah.
it spins the egg, and then you draw. Anyway, it's quite cool.
All right. Questions? Yeah.
I'm just trying to understand this one. So it's running MicroPython on the microcontroller as well as running it in your browser?
Yes.
So are you shipping Python code into the MicroPython instance on the microcontroller?
Yes.
You can push code and then read out.
Thank you.
On the logo device, it's emitting data back to Python running in your browser, and kind of the linking bridge are the underlying web APIs that Ted was talking about.
Yeah, but as you can see, like the idea is that, like if you think about a classroom of people trying to learn Python, just sending them to a website where they can start coding or connecting things without thinking, oh, now I need to download Python, I need to install those packages, I need to understand what is an environment, and what the difference between, oh, I'm running my editor here, and I need to go to the console and run Python to execute those files. A lot of that complexity goes away, and yeah, that's the goal is to really lower the barrier.
I love what Fabio says when he says we want to make it easy for people to do crazy stuff, and he means crazy in a good way.
Yeah.
This is about computing being creative, empowering, educational, inspiring environment, rather than, oh, I've got to read 15 pages of AWS related documentation about how do I do a Lambda function in blah, 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 blah. This is, instant feedback.
Yeah.
Get people in control of their computing devices.
Question?
Frequently when you're doing web development, you'll get a console and interact with the DOM. What's the best way to do that with PyScript, or is there a way?
Great question. So the question is, what's the best development workflow to go and interact with your code and debug things, etc. In JavaScript, we have the console. What is the best way for JavaScript? So today, I think the best way is to go back in time and think when we used to do a lot of debugging with print statements and checking the state of specific variables in the interpreter. Oftentimes, it's easier to use actually console.log instead of print, because also print has the terminal in it, etc. That's what I usually do. We are currently working on enabling running on web workers, which will allow us to have a full Python debugger in the browser. So you can stop execution and pretty much add breakpoints and do what you can do today with Python as well. But that's kind of in development. The other, I'll also be honest, there are rough edges. So sometimes when you have errors on the JavaScript side, it's pretty hard to understand where, but it's just the nature of the task. Pretty much like if you have errors in Python with async, that's another, like just in vanilla Python, it's hard here as well, right? So that type of things, the more you get deeper into difficult features, the harder it is. But yes, one of the goals is to make it easier. So we're working on it too.
I will say another favorite thing I like to do is if you can add a REPL onto your web page, right? So you can interact with your Python code that way. If you had, I think we showed that at some point. The py-REPL tag. It's like throw it in the bottom of your page. Like, what the heck's happening on the Python side too?
Yeah, I actually just did with them earlier. Like that's usually one of the things I do as well. A REPL, you put it there, so you can always interact with the state of your application.
And since we can create custom elements, there is some thinking about, can you inspect the Python runtime and understand what variables exist, what state are they in? So it's potentially something that you click, it opens a window over your app. You can sort of have a window that's peering into the actual runtime and seeing data as you're manipulating it. So, but additionally, we're also looking at debugging tools and trying to move further up the ladder.
Another question is, I know it's really hard to judge when you're working on projects like this, but what's your sense for when the first really stable version of PyScript is likely on the horizon?
If you pin your releases, it's extremely stable. That's the caveat there. You have to pin your releases because we're going to change things in a major way from one to another. But working against an individual one, it really is consistent, provided you don't change the URL to the JavaScript library.
Yeah. I would say, yeah, each release is a major release at this point, right? So if you pin a version and you upgrade, you should expect to have to change things. But we're trying to document those changes as best as we can and make them like new features you'd want to add as opposed to things we've taken away.
Yeah, I would say, so last year we did a lot of sanity work and sanitization work. Or insanity. But we are converging towards a specific workflow, specific APIs and things like this. So for core, I would hope that we are close to something we can call stable by the end of this year, right? Because of the big rocks in our way, we're kind of working on them right now. The web worker is a big thing. The other one, which is kind of related but also on the side, is packaging. Like there's no great solution for packaging on WASM today. So as a community, like a Python community, we need to start thinking about this. But for PyScript and core, I would hope that we can stabilize in this year. And then other things will still not be stable, like plugins and other things are going to be evolving. So it takes time. Like it took 20 years for Python to be stable, right?
I'd also say that this is an exciting time to get involved in PyScript. We're moving, I don't want to quote Mark Zuckerberg, but you know what I mean. We're changing things an awful lot and we're doing it fast. That's good fun. So, come join us.
Yeah.
We're in exploration mode, like Fabio says, trying to work out how does this fit together, because I can't remember who I said it to. It's like the browser and Python have had a baby, and we're trying to figure out what the DNA from each parent is going to be and how that makes that baby look. And at the moment, we've kind of got, I don't know, Baby Yoda with... yeah, exactly. It's got to grow a bit, but come help us.
Yes.
Make it grow.
Yeah, I want to double down on what you're saying. Like, we are assuming a lot of use cases. And over the last year, like a lot of people showed interest. PyScript has been quite popular, but we don't have that much visibility what people are doing with this. One of the things that we really are excited about PyScript.com, which like we just launched 3 weeks ago, right, is as people publish their public applications and whatnot, we see what they're doing, what are rough edges, what generates a lot of errors and exceptions and this, so we can actually, work on for our users, not out of assumptions.
There's another aspect of this, and this isn't sales mode, by the way, but the paid features of PyScript.com support PyScript as well. This is about making a sustainable open source project rather than having people burn out. There are people who are working on this. It's our proper job. And at 5 o'clock or whenever we clock off, I go off and play football with my kids or whatever. I'm not going, oh, no. I've got to triage a whole bunch of stuff in my random home project, as it were.
Yeah.
We want to do this properly. So we're experimenting in that sense as well.
So one of the things, I know there were a number of people who had problems with file writing and kind of the autosave behavior. I was actually back here filing bugs with the team, and they're actively deploying a new version that fixes that issue of autosave. We do care about the experience you have with what we build, and we want to make sure that your feedback, it matters, and it helps us move forward. So thank you.
Yep.
Can you say some good words that make me not feel creeped out that you're going to harvest all of my code I put on PyScript.com and,
By default, anything you put on PyScript.com per the privacy policy is MIT license. We're not planning to harvest anything from users' accounts in any way, shape, or form. And in time, we feel that that data needs to be controlled by account owners. And part of what we're moving to is private projects, control over how the subdomains are rendered, control over your URLs, and control over your data. We think that's a good service and a good business. So that, again, it's in line with where we're headed.
It's about empowering you.
Yeah.
That's what it is. It's like Peter said in his keynote last year, it's for the 99%. It's about empowerment. And if we're not good open source citizens, we're doing the wrong thing.
Yeah. Also, I want to make sure that this is clear. PyScript.com is totally optional to use PyScript.
Yeah.
We suggested using it for this tutorial because it took 1 minute for everybody to get set up, right? If we suggested, let's go to the repo, clone it, or let's open a HTML file, open your editor, and this and that, it will take more time. That's basically it.
We were explaining this to one of the users here. If those 2 link and script tags that are in every index.html file, if you go to them, if you copy them into your project, if you put them in your HTML file, you are running PyScript, right? So here on GitHub, if you copy that into your HTML document, you are running PyScript in your HTML, PyScript.com, locally, whatever, right?
Yeah.
That's half a more steps. We skipped it for today, but you can do it.
Yeah. Any other questions?
Are there ways to make PyScript viable for multi-page applications where you're reloading and having to reload this guide or interpreter every time? Or is it really mostly for single-page applications?
Oh, I see. Okay.
So
I
I could talk about cards and things. So,
but that's single page.
that's a single, but it looks
Multi-page.
So, HyperCard from the 1980s was awesome because there are only maybe 3 or 4 core concepts, and I can tell you them now. Okay, your app is made of a stack of cards. Each card tells you what's on the screen. Okay, and depending on what you do with that card, it fires transitions to other cards, and it's in that transition that you have the business logic. Okay, that's it. And so PyperCard, which is what Fabio was using for his presentation, is that reimagined as a single-page app with PyScript underneath, sort of rendering and doing all the things. But what it means is that your PiperCard app looks like it's a sort of a multi-page app, because what you're doing, in fact, is transitioning in exactly the same way as HyperCard's core concepts are between cards in your stack. The reason we wrote that is because I can imagine explaining that to a classroom full of 11-year-olds and them understanding it. In fact, I could give you a whole bunch of cards and you could draw your app on those cards, stick them up with drawing pins, draw with bits of string or colouring pen, what does what. So you plan that it's an unplugged classroom activity. 11-year-olds can understand it. I'm sure you folks can understand it. And yet, you get the full power of the browser and all the APIs and all the things that you can do here. Now imagine that imagine that, just imagine it, the potential you can use.
I think there are some browser innovations that are occurring. The WebAssembly the WebAssembly APIs are in transit. They're changing. And there are projects related to saving state, persisting state, and allowing state to run in worker context and across multiple pages. There is a service worker API, and service workers are a form of worker, but essentially it allows you to track network traffic and kind of play things back. So I think what we're going to see is some convergence around having a worker that moves across, that allows you to run it across pages, but at some point is shut down. We can actually do quite advanced caching with the PyDide runtime. And we have certain service worker cases where if you denote the URLs that the PyDide needs, you can actually create a local cache, essentially a local kind of store, so that you don't have the file I/O going across the wire. You're essentially instantiating the WASM from saved memory and the like. I see things changing. They will change, but we're going to evolve with it, and it'll be interesting to find out where it actually goes. But these are problems that the whole web has. You can't have JavaScript that runs across multiple pages. It's constantly burns it all down and builds it all back up every page.
Yeah, the main gap, I think, between PyScript apps and native JavaScript apps right now is the loading time, right? And that's something we're currently working on. Once we have support for MicroPython out of the box, we're talking milliseconds, not seconds to load.
On these sorts of devices.
Yeah.
Not just beefy laptops.
Yes, and there are some rough edges on PyScript itself as well. We're being a little too generous on stuff, and we should trim a lot of things down. Like, for instance, the PyTerminal is enabled by default, but it's quite heavy. We want to trim all those things out, so if you don't need them, it loads just instantaneously, and you can add things after loading time. So I think that's the main gap that I see today between the web and PyScript.
What would be an approach to configure your PyScript installation? We have a different URL that fetches latest, full or latest triple version, or it would be like an extra tag in your script tag?
Great question. So the question was, when we have that, what would be the option? Would be different builds of PyScript that contains certain aspects, or a configuration or something else? Is that the question, right? Yeah, the way we're thinking is to have the PyScript just the bare bone core, the minimal, very small, and then through your TOML file, your configuration, you say, I also wanted the PyTerminal, this and that. And in loading time, we're going to fetch them and add to your environment. So if you don't add anything, it's blazing fast. If you add, basically you're paying for what you asked for. Right now you're paying for everything, which is not good.
There's also browser caching as well, which is the other story. There's our to-do list, just as long as our, but there are, for all the questions that you ask us, one of our answers is going to be, in the browser, you could do, we, because this is an early stage project, are investigating what could be, but these are all big blips on our radar.
Yeah. we have actually, just to add last thing, we actually, to talk about this, we have a bunch of solutions for those things. It's just a lot to do and with not enough time. So on the caching of the browser and stuff, if you look for a post from, I think it was on the Talk Python to Me podcast, or it was Mike directly post. He showed using setting a progressive web application with PyScript, and that caches everything. So instantaneous loading time, right? So that type of things, yes, is what we're looking for.
You see, we get excited about this. A progressive web app is download me this web page so I can run it as if it were a desktop app. Problem solved.
Yeah. Sorry, you had a question.
I was going to say, I've done some work with Docker, and I was generating really huge containers from my development environment. And then when I realized that I had to pull a bunch of stuff out because I didn't need it for the container I was trying to build, and I was able to take like a 4 gigabyte image down to a 1 gigabyte image, which, but is that what you're talking about?
Yes.
It sounds similar.
That exactly, yes. That's the issue. Like right now we're loading too much, and the next releases are going to trim down and trim down. Like every release of PyScript has been in that direction, to be honest.
But you have a total file, so you don't need, you're loading stuff you don't need, is what you're saying.
Yes.
Yeah.
Any other questions? All right. So last thing I want to say, we have a bunch of PyScript talks during the conference. If you want to check it out, we are probably going to do 1 or 2 open spaces as well. If you want to try PyScript, explore, and we'll be there to support with answering questions or help you, etc. And if you like the project, follow. We're going to be posting some of the examples and things like this on the Twitter account as well, so that especially the ones that we didn't share because we're not ready. And yeah, that's it. Thank you so much for coming.
Thank you.
Thanks very much.
Thank you.